My name is Richard, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family. I'm cloud hired.
So, I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired. Because of Google Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the GloCloud team.
Welcome back, everyone. We are back for the sixth session of our AWS Advanced Networking Bootcamp, and this is to prepare you for the ANS-C01 exam, and this is an AWS specialty security course. So we're back, and we're having all kinds of fun with us. Let me know that you are here by giving us a hashtag that says AWS Advanced Networking. And that way we know that you are awake, you are alert, and you are oriented. Also to let you know that if you've just joined us, we have labs that you can do. You know, this has been a very busy 3 fun days. I mean, really busy 3 fun days to be here. And we've had a tremendous amount of content to go over the last 3 days. And we have 2 additional days of hands-on technology content that you can watch, you can learn from, you can do, both in AWS and also on real networking gear, so you can truly see what's going on behind the hood. So welcome back, everyone. And we will begin in about a moment. Benedict is going to begin, and he's going to be discussing network automation, which is a really hot topic in today's world. So welcome back, strap in. Benedict will begin, and Benedict and I will be going back and forth throughout the day.
Thank you, Mike. Okay, so now we want to talk about network automation. But before we talk about that, I see that there was a question in the last session that we did not address. So I'll just address it quickly. Someone said the administrator with the root account left the company. So they don't have access to their root account anymore. So a couple of things you can do. So first of all, you can be proactive about this and reactive. So let me talk about the proactive measures first. Being proactive means having in your security policy, right? A definition of how administration accounts are kept. So for example, in this case, you can define in your policy that root accounts be kept in a password vault, such as KeePass or LastPass. And in that way, if anyone leaves the organization, the other administrators still have access to the password vault, right? Another thing is that you can implement some form of dual control there and say, instead of one person to have the root credentials, let 2 people have it. And one of them must be senior manager or something. So those are proactive measures to, ensure that your root accounts are not taken by a disgruntled staff who leaves the company. Now, being reactive about this, I assume that the administrator used his company email account to register on AWS and get the root admin account, right? If that's the case, you can enable the user's email and then go on to the AWS console and try to reset the account. It's going to send a link to the administrator's email, and then you just follow the steps to recover the account. Now, if there's two-factor authentication attached to that account, it could go both ways. I mean, if it's a situation whereby two-factor authentication apps are only installed on company-held devices, then it is assumed that when that administrator was leaving the company, he dropped his company-managed phone, and then from there you can get the code and get back into your root account. Now, if that doesn't work, you have to contact AWS support. I'm sure they've had issues like that before, and they'll advise you on how best to proceed. So let's talk about network automation. Now, what is automation? It's basically the use of technology to perform tasks with reduced human intervention. So what does that mean? I wake up in the morning and I want to listen to my favorite song, Don't Worry, Be Happy. Actually, that's not my favorite, one of Mike's favorite, right? So I go into my phone, and then if I've downloaded a song, I just click on it and play it. If not, I go to YouTube and, play the song, right? That's human intervention. How about if I have Alexa? Alexa, play me Don't Worry, Be Happy. And there's reduced human interaction with the system because there's an automation system in place to play me my song. So that's what automation is really. It kind of helps to make things easier for the administrators of the network, right? Now, in that light, network automation is the process of automating the planning, deployment, optimization, and operations of networks and their services. So what's going on here is that it's using programmable logic to manage network services and resources. So it takes out all those manual steps of logging into the switch, logging into the firewall, creating an access list, deploying it, verifying that the access list works, and stuff like that, right? Here you do everything in code. There's a program available for you to carry out all these processes. So it kind of makes life easier. But we have to be careful so that we don't break things in our bid to embrace automation. Now, what do I mean by that? Take, for instance, you have 1,000 switches in your infrastructure, and it's in part of your policy that you take backups once every month of your switches, right? So normally you have to log into this 1,000 switches to take the backup, but you can have an automation policy that says on the 28th of each month, take the backup and save it in the object storage, right? This is an automation policy. It makes life easier for you. But what happens in a leap year when February has 27 days? Your automation policy does not work. And if there's a disaster in the first few weeks of March, it means that the latest backup you have for your switches is going to be in January and not February. So let's kind of keep that at the back of our minds. Now, how does automation work really? And it usually exists between command line and automation software really. And there are a number of softwares that help to enable automation, right? So if you're doing automation on-prem, you have a lot. You can use Cisco Prime infrastructure to configure a bunch of switches at the same time, rather than logging into each Cisco switch to configure it, right? So you have solutions available like that, but it's usually going to be between a software solution, automation software solution, and the command line interface, right? So let's look at it at the basic level using command line interface. So you have a bunch of Windows PCs in your organization. You could write a script, right, to download the latest antivirus on these PCs by maybe 5 p.m. and then deploy it in across these PCs at the same time. So that's using the command line interface to achieve automation, because you're going to run the scripts in CMD to achieve CMD on each individual device to achieve your aim. You could use an automation software policy, and in this case, it would be, for example, a Microsoft service available for you to, patch your systems, right? So there, it's just series of clicks, select the systems you want to patch, and then start the policy for them to download updates and install them, right? A very popular example of a software automation policy is Ansible, right? And it's very useful for a number of organizations. I'm sure the major service providers, cloud service providers, also employ it to drive automation in their data centers. And the way Ansible works is that it packages APIs, inventories, and playbooks that users can browse and then select to run common network configurations. So you'd log into the Ansible software, and then you see options to take backup of all the switches, configure banners across the switches and stuff like that, right? So instead of logging into these switches individually to carry out all these tasks, you could just run the tasks from the Ansible software, right? So it kind of makes life easier for us. So why do companies automate, or why would you automate in the cloud, right? So it helps to reduce configuration errors. So let's take a scenario. In your security policies, it has been determined that all network devices should have a banner saying this property belongs to Go Cloud carriers. Please log out now, or you can be prosecuted for this. So imagine if I was to do that in 1,000 switches, I could make a mistake on one of the switches, right? And then the text will be slightly altered. But if we're using an automation policy, right, it's going to reduce this sort of configuration errors, because it has a template that is deploying to those switches, network devices at the same time. So it has the potential to reduce network downtimes due to misconfigurations by administrators, because you have a standard template that you're just pushing out to all the devices. Now, this is a controversial one. It lowers the cost for an organization because it can reduce the number of administrators managing systems. And what does it mean? Recall the scenario I gave earlier, that if you have 1,000 switches in your organization and you have to manually log in to take backups of everyone, of all the switches, it's going to be a hell of a lot of work for one person to do. So in that sense, you have 5 network administrators, and then they can cover all these switches at the same time, right? But if you have an automation policy in place that can do the backups, right, through a click of the button, then why do you need 5 network engineers? So it lowers the administrative costs for companies in that regard. Now, it allows network teams to become more agile and flexible and support modern business demands, right? So they have more time on their hands because they have automation policies in place to drive the network, and then they can focus more time on research and development to aid the growth of the organization. So these are some of the reasons why you would want to engage in automation. Now, Mike mentioned something about event-driven automations, right? So I'd just like to expand on that further. So what's an event-driven automation? So it's a process of responding automatically to changing conditions in an IT environment. So what does that mean? I have a system in place responding to requests from users, and my CPU utilization is hitting 90%. That's an event. An event-driven automation policy will auto-scale this virtual machine and increase the CPU capacity so that it can respond to these requests without crashing. Now, ordinarily, if that was not in place, it means the administrator would have to, maybe put in the server in maintenance mode and try to add CPU resources to it. So event-driven automation becomes very valuable in this sense. That's just a basic instance where we can use it, right? So, I mean, it reacts to triggers, right, such as incidents on your network. So another very popular example of that will be an intrusion prevention system, right? It's a sort of event-driven automation. So it's looking at the network, looking at traffic coming into your organization, and then it sees something funny. It takes an action and drops that packet, right? So there's been an event, which is a funny traffic is seen, and it reacts to it by dropping the traffic. So it's basically a system, it's basically a solution that tells the system that if this happens, right, then that should happen to counteract it. So it could be very, very useful in that regard. And it's we often see it employed in the cloud, where you have auto scaling, right? So if the resources of your virtual machines are being used, or you're suffering a DDoS attack, for example, that is trying to drain your CPU and memory utilization, then upscale till when the DDoS attack is tired, and then you can now contract back. So very good example of an event-driven automation. Now, how does it work, the event-driven automation? When an event is detected, right, the automation policy will initiate scripts and workflows to counter such an event. And there are 3 main parts of an event-driven response. There's the event, there's the action, and there's the result. The event is the activity that occurs within the system. So take, for example, you have a DDoS attack to one of your servers. That is the event, right? Now, the action is the predefined action which is triggered and deployed as planned ahead of time. So you have a policy in place to auto scale your virtual machine if the resources are running low. This is the action. So that if the resources are running low, then upscale and increase my resources, right? And then we have the result, which is basically the reports or the analysis I sent back to the administrator saying that event happened and this took place to counter the event, right? So you want to have a full grasp of what's going on in your automation environment. Now, why would you use an event-driven automation solution as an organization or a cloud engineer, right? So first of all, it helps to mitigate risk, right? Because it's kind of proactive than reactive in this sense. So it's responding to abnormal behaviors in your system just to make sure that your systems are up and running and safe and secure at all times. So it helps businesses to become more robust because of this proactivity, right? Now, another thing that it can enhance is the accuracy and efficiency of deploying network resources in the cloud, right? So you have some infrastructure in the cloud, right? And normally you have to go in manually through the GUI or command line interface to configure these devices, and you could be prone to making errors. Human error is one of the major causes of security incidents, right, in IT world, and it's pretty understandable that sometimes as human beings we tend to drop the ball or make mistakes here and there. But having an automation policy ensures that you're always churning out the same configurations to your infrastructure at all times, right? So it improves scalability and overall compliance with minimal manual interference. Now, we also spoke briefly about infrastructure as code yesterday, but we didn't really go deep into it. So let's just have a more advanced discussion here. We're not going too deep because, I mean, you just need to know the basics for the exam and for your daily activities, right? But what exactly is infrastructure as code? Pardon me. Now, infrastructure as code is the ability to manage your infrastructure using code rather than manual processes and settings, right? So I want to spin up an application load balancer in AWS. I log into the console, go to application load balancer, create the targets, create my policies, apply security groups to protect the instance, and stuff like that, right? Place it in a subnet and apply network access lists to protect that subnet, right? With infrastructure as code, right? I just need to write a code, right? Using any programming language, Python, for example. And then I define all these characteristics, saying in order to spin up an application load balancer, use this security group, permit traffic from 192.168.10.1 to this, right? For the access list, deploy it in subnet 10.0.0. So I have all this in code, and then it's a code template I have that I can push out at any point in time to create the same version of application load balancer that I want. So if another administrator we're doing this manually, setting up an application load balancer, he could alter some settings, based on his own understanding of the infrastructure, which will not give you a baseline configuration for all application load balancers in your organization. But if you have it in code, you can always deploy and reuse the same code at all points in time. So it uses a coding language, right, to automate the provisioning of IT infrastructure, right? So it prevents that manual work from IT administrators. So you see DevOps teams and DevSecOps teams employ infrastructure as code a lot because they're always pushing new applications and new solutions regularly. So they need something to make their life easier. They don't want to be logging into the console to create Lambda functions and the rest of them. If you have it in code, just push it to the cloud and you're good to go. Now, how does infrastructure as code work? Really, what is happening is that there are configuration files, right, which you define ahead of time. And then these configuration files will be read by software. And then the software will use the files instructions to define and configure infrastructure. So in that scenario I gave you earlier about the application load balancer, you have the configuration file that says deploy this application load balancer with these characteristics, right? And then you have a software picking that configuration file and reading it and deploying it through code to the infrastructure. Now, a very important aspect of infrastructure as code is that when you need to make changes to an application, for example, in this case, the application load balancer, what it does is that it takes the baseline configuration for the application load balancer and then makes the changes on the baseline and deploys it, right? So it doesn't go and start to update and modify existing infrastructure, right? It takes the baseline, adds the changes to that baseline, and then deploy it. So this helps to maintain some consistency between deployments. It enables you to do what we call version tracking, right? Because you have an audit trail of the changes that you have made on the baseline config at every point in time, right? So very useful to auditors. So of infrastructure as code would basically comes in two types, right? There's a declarative approach and the imperative approach. In the declarative approach, you say, you tell the system, I want you to give me a web application firewall. I don't care how you do it. And then the system generates the code and deploys to the cloud. And you go in and log in to see if everything is cool. In the imperative approach, you actually define a sequence of activities or sequence of commands that the infrastructure will use to deploy this web application firewall. So you say deploy in region this, deploy with 2 gig of RAM, deploy with 500 gig hard disk space and stuff like that. That's the imperative approach. And common infrastructure as code tools that you would see organizations use Terraform, Ansible, and in AWS, CloudFormation. So CloudFormation is an infrastructure as code tool. So you might want to keep that at the back of your mind for the exam purposes. And now, why use infrastructure as code? Well, just as we mentioned when we talked about the benefits of automation to the organization, it reduces IT costs because you're able to do more with less IT staff, right? So administrative overhead is reduced. It improves the availability of the IT systems because it eliminates those errors that are associated with human fatigue, and when they are doing things manually, because they're doing things with a standard coding template now. It actually reduces amount of errors and helps to improve the availability of your IT systems. It provides an opportunity for you to have configuration management, and configuration management is basically having the same configuration baseline for all your devices. So, for example, if you want a baseline of AES 256 encryption for your S3 buckets, right? You can use infrastructure as code to apply this, as opposed to when the S3 buckets are being built manually by cloud administrators or cloud engineers who could alter that encryption algorithm, right? So it helps to give you that consistent configuration across your IT infrastructure, which will help to mitigate risk of different personnel manually deploying configurations. And then it helps with accountability as well, because there's version control. You can always go back in time to see what has been deployed in your organization, and it could help you make more informed decisions. And these are opposed to when administrators are going in and doing things manually. So I could go in and set a banner saying, this is Go Cloud Carriers, please do not enter. And then there's a scan that the IT security team does weekly. And the scan picks up that banner on that device and say, no, this is not our standard template. If I see that information ahead of time, I could go quickly into the system and change it back, right? And put the correct template. But because there's no version control, right, it will be an argument between myself and the security team that, no, I did the right thing. Your scan must be faulty, right? If you have version control in place, you just go and look at the last version of code that was deployed to create that banner of that device and tell you if it was configured correctly or not. So these are some of the reasons why we would want to use infrastructure as code. So it gives you that documentation control, because for each code that has been deployed, you have a version that it saves, right? It can help you in your documentation. When so there are different types of auditing, right? So there's a type of auditing, SOC 1 type 1 reports, where the auditor comes in and just asks for your configurations and then goes through it without actually verifying, right? So it says, okay, these are in place. And there's another type of reports whereby the auditor comes in and actually does some tests on your system to see if you're running standard configuration templates. So if you have infrastructure in place, infrastructure as code in place, because you have all these version control templates available, you can hand them over to the auditor as your documentation for your network operations. So these are some of the reasons why we would want to use network automation using infrastructure as code. Can pause now for some questions if you have any before we go on to the next content.
Welcome back, everyone. Does anyone have any questions? Either on what I had covered this afternoon or what Benedict had just covered. So name not found. What's the best way to get more competent with the CLI, especially for someone who hasn't used it before? So name not found. The first thing I'm going to say is let's first figure out what career you want. And here's the reason I see it. I find a lot of architects who will never touch the technology in their career really want to get hands-on, and they work so hard to get hands-on that they don't learn how to design the systems or how the systems work. So let's first just make sure that's the case. Everybody should probably learn how to configure it. The question is, how much time and where you focus your effort really is going to be determined on your goals. So assuming you want to be a cloud network engineer or a cloud engineer where you're going to be in a hands-on position, best way to get used to it is literally to go build stuff. So take a problem, go build it, do it via the CLI. When it doesn't work, go debug it, go troubleshoot it, and you'll learn it. But the more time you spend on that CLI, you'll get there. And try to do as much as you can with the CLI. So for example, I think you're in Egypt. I don't know if I picked that up correctly. So, if you were to go to Greece, which is pretty darn close to Egypt, and you were to live in Greece for 6 months, chances are you'd learn Greek. Likewise, if you take a Greek person like me and you send them to Egypt, we're probably going to speak Arabic after about 6 months because we're immersed in it. And the key is the more you get immersed in the CLI, the more you will pick it up and it will be more of a natural language to you. So, that's one of the reasons at CCIA Labs, people spend all this time configuring things. The job is knowing what to configure, not how to configure it. That's the easy piece. But we have to be fast when we have to configure them. So that's why we spend all those times in the labs configuring, and that'll get you real good at there. Let's go to the next question. Do solution architects need to script? In a normal solution architect role, you'll not be allowed to touch the technology. You will be meeting with clients. You'll be asking about their business. You will be facilitating meetings, managing vendors, managing stakeholders, negotiating with vendors, negotiating with stakeholders, leading large teams, getting buy-in, delivering presentations and sales, and you will not be allowed to touch the technology in a real traditional architecture role. Now, there are some people that have engineering roles with an architect title, and in those roles, they might actually need to do engineering things, but they're not really working as architects, they're working as engineers. But as a rule, architects are not a hands-on position. Now, here's the thing, Sonny, you know what? This Thursday, we're going to have a How to Get Your First Cloud Architect Job webinar. My team will pop in the link. We'll cover everything that we do as cloud architects and solution architects, what our job is like, the specific skills we need, because they're different skills as architects than in these certifications. And we'll do it live, and you can ask me questions live. I can interview you live. We can do anything we can. It's completely free. And this next week, I think it's going to be me and another major cloud leader that's going to be on there as well to join me. Cantor Grant, do you recommend architects advertise their cloud provider badges and other stuff that shows I did consume some courses, and why? Cantor Grant, I do like my architects to have some badges, some, but not too many, and we have to be careful why. When you take too many AWS training things, you get biased towards AWS products and services, and that makes you really a bad architect. Why? Because if you're too biased towards AWS, you'll ignore all the other things you can do for your clients. If you have too many Google badges, again, it's going to make you biased towards Google. So yes, typically speaking, about 3 good certifications for an architect is good. A nice architecture certification, potentially a TOGAF certification, a cloud provider solution architect certification like the Azure Solutions Architect Expert, Google Professional Cloud Architect, or the AWS Solutions Architect Professional, and potentially one other certification like a CISSP for security. So yes, we do want to show some certifications because certifications build our brand and it makes us look good like we've done the work, which is wonderful. The problem is all of these certifications are geared towards the name of something and how to configure it, which are more based on building or systems administration roles. And when we're an architect, we're an executive that's going to be a strategy consultant to our clients. So if we have 100 certifications, we look like a hands-on techie and not an executive strategy consultant, and we can potentially damage our brand. We'll cover that actually in the free webinar as well. So it's about getting just enough certifications to get that entry in the door, and not so many that you get perceived as the techie when you need to be seen as the business executive. It's a great question. Okay, so I can do one or two of these things here, and I'll do the next one from Canner, and then we'll go back to the content. So should I advertise certification, but not the small stuff you do with them? Advertise the big ones. So I'd put my CCIE, I'd put my Google Professional Cloud Architect there, and I may put a TOGAF. I'm not going to put a Solutions Architect Associate if I have a Solutions Architect Professional. I'm not going to put a Cloud Practitioner if I've got a Solutions Architect Professional. Only the big ones. And when you get super high in your career and you reach executive architect levels, my manager asked me to remove the CCIE and he removed the CISSP, because at that level, we need to be seen as more strategy consultants than tech professionals. But for the majority of you that are taking your first architect job, senior architect before you move into principal architect roles, we want 2 to 3 really good certifications on the resume. They will help you stand out. So, and Sunday, I would love to answer your question here, but the issue is, to prepare you for an security architect interview, that typically takes me about 8 to 12 months to prepare someone for a security architect role. Not something where I'll give you just a couple tips and you'd be successful. If I could, believe me, I would. I really wish I could, but I don't know what they're going to ask you, and I don't know what you know, and I just can't summarize, 800-900 hours of training inside of 5 minutes. I wish I could, because believe me, I would do it. All right. If you're here and you haven't gotten the labs yet, please register for the labs. Want to make sure you have access to everything. And because we've got 2 full days of good tech training that I want you to get, in addition to these 3 full days that we had here. Let me know you're awake by giving me a hashtag AWS Advanced Networking. If you haven't liked the video, there's 57 of you. I don't know how many likes there are so far. And I know lots of people come on and off. Maybe give it a like. Signal the algorithm so this free training can make it to more people. Okay, so we are going to get to the content. And as a reminder, I will do next week a How to Get Your First Cloud Architect Job webinar, and it will be live on Zoom. And you can literally go and ask me anything. And I've gotten architects hired at Apple, at Amazon, at Cisco, at Google, at IBM, Accenture, Deloitte, KPMG, Capgemini, PricewaterhouseCoopers, JP Morgan Chase, Barclays Bank, and I will help you on this free webinar. Okay, so I am going to come back and I'm going to talk a little bit about securing your VPC. And I love security, spend a lot of time in security. So we're going to go over some basic principles, and maybe I'll whiteboard it out for you to kind of help. And this will probably help with that security interview tomorrow anyway, to some degree. So the first thing we want to do is keep unwanted traffic out, okay? If the traffic can't hit you, it can hurt you. Kind of like a boxer. If they can't get hit, they don't get hurt. So what we're going to do is we're going to try and protect our systems with DDoS. And then we're going to protect our subnets with access control lists. We're going to protect our hosts with security groups. And then we're going to try and use some host-based firewalls and IDS, IPS systems. So let me kind of map that out for you, live in real time, so you can sort of see what it actually is going to feel like. So let's look at it this way. Bear with me a second. I'll create a whiteboard and we'll work on it together. So let's say this entire thing is your VPC. This is everything that you own in your virtual private data center. And in your virtual private data center, you're going to create multiple subnets. We'll make them different colors. So this is going to be subnet 1. Let's make this subnet. That's not going to work. Let me undo that. That'll be subnet 1. Over here, we'll have subnet 2. Let's make this another color. Now, there's this guy on my team, Alonzo, where he can make things look beautiful with colors. I wish I had half of his skill. Great guy also. But subnet 3 over here. So bear with me and my graphics. And then we'll have subnet 4. Yellow looks like a happy color. So let's assume this is the edge of our systems before we'd go to the outside world. We're going to put a firewall and protect the organization from the outside world anytime it needs to connect to anything else. So we can do that. Now, if it had been a web application, which we'd have a demilitarized zone architected, which is beyond the scope of a certification. But let's just say for the arguments that you've got a CDN out here. You want to put your DDoS protection on your CDN, whoever's CDN you're using, and there's a lot of CDNs. On your firewall, ideally, it's a next generation firewall, something that's got some intrusion detection, intrusion prevention, what have you. Now, we want to protect these subnets, right? And that's where you're going to put in your security group. I'm sorry, you're going to put in your network access control list that are going to protect each subnet. And you can have sub ACLs in between your subnets, so that's going to protect your subnets. Now, inside of these subnets, we're going to have servers. So let's pop a different color server in here. Yeah, we'll have a server over here, and another server in here that sits in the subnet, and another server which sits here in the subnet, and we've got some more servers. So as you can see, we've got some servers in the subnet. We want to protect those servers too. So we can protect those servers, entry and exit of those servers and many of our services with a security group. And then if we want to be really smart, and if it matters in security, we will be, we're going to take these servers themselves and we're going to put a host-based firewall on them. In that way, in case the organization's firewall, the network access control list, and the security groups fail, we're going to have another firewall on them. We're going to have some host-based IDS, IPS systems to stop an attack if it notices an anomaly is going on. We're going to put on some anti-malware software for worms, viruses, ransomware, what have you. And we're going to harden these operating systems down. Now we've got some control over who's allowed to access what information, right? We can determine what you're allowed. What are you allowed? What are you author? Who are you? So who are you? And that's going to be your authentication. What are you allowed to do? That's going to be your authorization. And then we're going to be, what did you do? And that's going to be your accounting. And that's really what you're going to get from IAM. Now, in an enterprise environment, this stuff is realistically going to be sitting on Microsoft Active Directory. And what you'll do is you'll take your AWS IAM and you'll federate it with Microsoft Active Directory. And that way, all the enterprise's directory information, who's allowed to access what did you do, will that all be stored in a central place. So you can see what we did here in this environment. On a content delivery network, we put Shield. Our firewalls, hopefully are next generation firewalls. And there's going to be some specifics on how you would have to do that. We're going to protect our subnets with access list. We're going to protect our instances or hosts or load balancers with security groups. And then we're going to protect our endpoints. And then the last thing to talk about is routing from a security perspective. If you can't route it, if you don't have a route to it, you can't reach it. So when we connect our data center to the cloud, does the cloud necessarily need to access every subnet in our data center? If the answer is no, don't provide access to it, because if you can't provide access to it, it can't be hacked. So we're going to only advertise the necessary routes. In the data center, we can do multiple VLANs. In the cloud, if we need to isolate our organizations, we can place them in multiple virtual private clouds and route between them. So kind of think about some of these guidelines as it pertains to security. So lots of great firewalls that are out there. We talked a little bit about it. We talked about Shield, and we talked about AWS Shield and how you have the Shield and Shield Advanced for DDoS protection. We talked about network access controllers to keep unwanted traffic out of your subnets. And we talked about how to structure your network access control lists yesterday. We talked about what a security group is, how it's effectively a stateful host-based firewall to protect your systems. And talked briefly about, well, I don't know if I mentioned network-based intrusion detection and intrusion prevention in the past. I mean, I sort of did. So our next generation firewalls have the ability to monitor patterns of behavior and look for things that look like an attack pattern and stop them. And that's network-based IDS, IPS systems, very robust. We've been using them for a while. But I mentioned host-based IDS, IPS system, and there's really speaking one of two ways these systems can occur. Typically, you put a little agent on the computer, and the agent will communicate with the network-based IDS, IPS system. And if the IDS, IPS system notices things from the network, it can stop it. But we can also put host-based IDS, IPS systems that will actually sit on the server and look for patterns of behavior that are anomalies on that server, and then be able to stop an attack on that server. So that's what we're talking about with regards to host-based IDS, IPS systems. I talked about anti-malware protection. I hope it makes sense that you've got to take care of your worms, your viruses, that kind of thing. So I hope that kind of makes sense. And at this point, I think, actually, you know what? No, I'm going to tell you it's not Benedict's. So let's talk about security incident reporting and alerting. A security incident is going to be an event that occurred. It could be an event that actually started to occur and then you caught it and nothing happened. That's an incident. Or it could have been you've been hacked. So basically, anytime the confidentiality of the system, the integrity or the systems being what they're supposed to be, or the availability of the systems goes down, that's an incident. And incident reporting is really the process of documenting the details of a security incident so that organizations can track them, analyze them, and respond appropriately to an incident when it should occur. And a security incident alert is really going to be a notification which is sent to the responsible parties that a particular security incident or set of events has occurred. So how do we automate this? How are we going to automate our incident reporting? Well, the first step to really achieving any kind of robust reporting and alerting systems is by adequately collecting logs and collecting logs in the right place. Now, when we do our logging, we have lots of sources for logs, right? The VPC flow logs, which track the traffic through your VPC, whether your traffic's accepted or rejected. We talked about AWS config and what that's tracking. CloudTrail is your auditing. And of course, there's custom applications and servers that can also send logs. And you can send them to an external information system like a SIEM system, like Splunk, Rapid7, etc. Or you can send them to CloudWatch logs. And then once these logs are collected, they're going to be stored in a central location. And then we can use like CloudWatch logs or config or GuardDuty or Insights or Amazon Athena or other tools to go look at these logs, any type of business intelligence tool or visualization tool. So these are kind of some of the things we can do with regards to looking at things. Now, why are we going to do automated security and incident response reporting, and why is it so important? Well, you need to be able to respond to incidents quickly, because when something happens, you want to catch it, mitigate its impact, and then remediate it and respond to it as quickly as possible. But also, what if you're a regulated industry? You're going to have an incident report and an audit report. And in reality, as in any industry, you're really going to need to. And we're going to need to make sure our security teams stay up to date with the evolving threat landscape. And it's going to improve our overall efficiency and response time. So, kind of keep that in the back of your mind. That's realistically what we're going to be talking about and why we're going to do this. So I'll stop for a minute and see if anything popped up, and then Benedict is going to come back and start talking about network performance. Any questions for us? Does MS Entra replace Microsoft Active Directory? Cantor, is that what they call? Is that the new name of Microsoft Active Directory on the Azure cloud? I'm pretty sure. I forget, they have a new name for Microsoft Active Directory. Is federation the same as synchronization? No. So here's, realistically speaking, what federation is. Let's pretend that Benedict has a database of everything that of something, and I trust Benedict. So if you went to me to log in and I said, let me check with Benedict because I trust Benedict, and then Benedict tells me, and then I say it's okay, that's kind of federation. So you can think of federation as so let's say, have you ever logged into a website and they say log in with your Facebook account or your LinkedIn account or your Amazon account? What's going on is the company you're dealing with is then connecting to, say, Amazon or Facebook or Google, and they're saying, do you recognize this user? Could you give me this user's credentials? And then they get sent back to us and we trust them. So that's federation. Yeah, so that is, so if that's the new version of Active AD in the cloud. But, you know, we always have to think of what's going to be surviving what and how we're going to be using it across clouds. Let's go to the next one. How does the firewall protect against known patterns? There is something called signature patterns that exist. And basically, signatures are what an attack actually looks like and how it actually occurs. So it kind of works the way the human body does. If I get infected with a particular virus, my immune system will see the virus, it will build up an antibody to the virus, and I'll be protected from getting that virus, in most cases, ever again for the rest of my life, because my body will develop a signature match to it. Now, in the world of attacks, in the world of viruses, we've got software that's trained to actually look for a pattern that it knows, and we create what's called a signature for it. And then again, anytime it sees the signature, it knows how to defeat it. That is against a known attack. It's based upon a signature. It's kind of like this. It's kind of like if you're a martial artist and somebody keeps coming at you with a hook punch, and you just know how to block that hook punch with the right kind of defense, and you're not going to get hit. So that's a known pattern. But all of a sudden, that boxer's coming at you with a hook, and they don't come at you with a hook, they come at you with an uppercut, and you don't know how to block an uppercut, and you get hit. But then once you learn how to block that uppercut, you can block now the hook, you know how to block the uppercut. That's kind of what we're dealing with here. Sorry, there's some boxers and martial artists on this on this instructor panel. Good questions.
Cantor Grants is saying, but the Azure service in the cloud completely replaces the Microsoft Active Directory organizations used to have in their data center. Not entirely. I mean, you could synchronize your AD on-prem with the Azure Active Directory service in Azure. It's not a complete replacement.
Yeah. And architecturally, I think about this. What if you just completely trusted on the Azure Cloud's directory services for authentication? And you have your own data center, and you also have systems in the Google Cloud. And then the whole Microsoft Cloud goes down. And everything you have that determines who's allowed to access what is now down. Effectively, your Google Cloud and your data center would be down too. So we have to be careful where we choose to architecturally put these services and where we want to spread them, and whether that fully managed thing that's so convenient because, oh, that's really great, we don't have to think about it, is really the right thing or not for us. Well, Benedict, am I next or are you next?
I think you're next.
Okay. Sounds good. Then that works okay too. So how does the firewall protect against unknown patterns? Okay, so now not all firewalls can do this. Firewalls use something called heuristics, and now they're using pattern matching and artificial intelligence, and they look for things that are normal. Benedict, when was the last time you left your house in Canada, decided to go to Paris, Abu Dhabi, stop in Lagos, and then go to Cape Town all in the same week?
Never.
Right. Now, would it be normal to assume that you're going to do this on a normal week?
Nope.
And so the firewall is doing the same pattern matching that your credit card company is. Benedict goes and buys a ticket to London. He's got no problem. It's a normal thing that a person might do. While he's in London, 3 days later, he goes to Paris. Again, it's probably fine. Now, when he goes to Abu Dhabi, which is a beautiful place, I haven't been there a long time, but a very beautiful place. Now, it's not normal for him to be in 3 continents or 3 parts of the world inside of 1 week for Benedict. And that credit card company will flag it. And his credit cards will be shut off, and I'll have to call the credit card company. Oh, sure, we're on a trip. Yeah, we'll open it up for you. Thanks for letting us know. Now Benedict gets a job as an executive architect, and Benedict's that good, he will get one of these executive architect jobs. And now Benedict needs to go all over the world. He starts his day in Canada, then he's in London, then he's in Dubai, then he's in Cape Town, then he's in Sydney, then he's in Hong Kong. And guess what? Now it's normal the credit card company learns that behavior. And that's the way these systems work. They look for those patterns. Okay, these were great questions, and I'm glad you asked them. It took me a minute to recognize one question from another because they were so similar, but they were great questions. Okay, so let's talk a little bit about network performance. I love network performance. So we'll begin talking about networking. Now, no matter what you do to your system, if the network does not have sufficient bandwidth, things are going to fall apart. If there's too much latency on the systems can and will fall apart. And I will tell you that in the last 25 years of being a network architect, most of my time was spent redesigning networks that were not designed to meet an organization's needs. Nearly every network that I ever saw had routing protocol problems because people did not either understand the IP addressing piece or they didn't understand the routing protocols well enough and how to tune them and how to optimize them. Now, the good news is when you're on AWS, most of the network is managed for you, most of it. And because it's managed for you, they typically have very good network engineers. So a lot of the traditional networking problems we see aren't going to be as bad on the cloud. Plenty will be, but some of them will not be. So keep that in the back of your mind. And when it comes down, let's talk about some network performance metrics and reachability constraints. Network performance is basically the analysis and a review of the performance of the network through the eyes of the user. In order to measure network performance, we need to be able to define metrics that would be employed. Networking metrics are going to be quantifiable. How many milliseconds of latency? What % of packet loss do we have? What type of throughput are we achieving on these lengths that we need to be looking at? So think of bandwidth, speed, packet loss, those types of things. Now, we can have a lot of networking problems. If we don't have a route to it, we can't reach it, and then all of a sudden someone calls and say, I can't access this server. That's easy. But we may have other problems. We can have problems related to latency, jitter, insufficient bandwidth, and packet loss. So let's talk about latency. Latency is how long it takes to go from point A to point B. And if I am sitting in my house in Florida, it may take me several milliseconds of latency to reach something in Japan. Several milliseconds may feel like an eternity in damaged user experience. But what if the routing's not so great? We have one of the members of our staff, he's an incredible guy. His name is Eddie. He lives in Bamenda, Cameroon. It took him about 12 hops just to get to the internet. And we're to almost 10 milliseconds of latency before he even reached the internet, before he got off of his internet service provider's network. A lot of applications would struggle under the type of latency he had, especially real-time applications. So the point is we need to understand, latency, how long it takes to go from point A to point B. Most of this time is based on either sending electrons on a physical cable or photons or pieces of light on a fiber optic connection. One way that you can try to sort of check your latency is by just generally sending a ping. And what a ping is an ICMP echo message that goes to the server and then a reply. So you have to divide that by 2 to try and figure out what's going on. And in a good line, your latency is going to be fairly consistent. So here's a ping that I actually took when off of my network to Amazon. And you can see I've got a really good network here. You can see my first, second, all the ICMP messages I sent, 27, I got them back, so no packet loss. You can see that the TTL, which starts at 255 and gets degraded by every router, is 231 each time. So I took the same symmetric routing hop each time. And you can look at my latency. It's fairly specific, consistent. 20 milliseconds, 20 milliseconds, 20 milliseconds, 20 milliseconds. Pretty much the same. So this is what a good line would look like. But a bad line could look a little different. A bad line may have something called jitter, which we'll talk about in a minute. But imagine this latency was 20 milliseconds, and this one was 5 milliseconds, and then the next one beneath it was 50 milliseconds, and then the next one was 100 milliseconds, and then 5 milliseconds, and then 10 milliseconds. Jitter is a disaster on voice and video, and jitter is really just variations in latency. But also consider, what if, for example, the first packet, sequence 1 came back, and then I lost, sequence 0 came back, and then sequence 1 came back, but I lost 2 and 3, and then I got 5, 6, 7, and I was losing some. That would indicate packet loss, which would again be a bad thing. So kind of keep about that. So it's one of the very simple elemental things you can do from any router, switch, pretty much any server where you're at. So you're going to have to look at what your latency is, and latency is going to vary. Here's a screen grab I took off of my firewall, or the management dashboard from my firewall. You can see what my standard uplink traffic was. You can see it was at a time I wasn't really using much traffic at all. And you could see the latency of my link was pretty consistent, and I had nearly 0 packet loss when I ran this test. Okay, so now let's talk about jitter. As I mentioned before, jitter is variations in latency. So slow, fast, slow, fast, slow, fast, 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 slow. And that causes out of order packet delivery. Because if packets 1 and 2 were sent at 5 milliseconds, and packets 3 and 4 were sent at 100 milliseconds, where it took 100 milliseconds, but 4 through 50 got there in 10 milliseconds, you can see that we're going to have out of order packet. So that can wreak havoc on a video stream. Generally speaking, if latency is consistent, it's typically not too much of a problem. Well, some applications it is and some it isn't. But when there's variations in latency, that gets bad. You're watching a video and all of a sudden you've got some jitter and you get that squares pixelization on your screen. That's typically where it's coming from. Now, here's what I did. This was a little more fun. I took my Mac Pro and I opened up a terminal window. Look at this. What I did is, instead of sending my internet data out my internet connection, I used my 5G mobile phone. Now look at this. Look at this difference in latency. Not 20 milliseconds, 62 milliseconds, 59 milliseconds. That's icky. 68 milliseconds, 47 milliseconds, 76 milliseconds, 92 milliseconds, 63 milliseconds. Anybody see a problem with that? I've got a lot of variations in jitter, and this is not good for any kind of voice or video. I also lost a little bit of data along the way. If you note, there's 3% packet loss. Let's see where we lost it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15, 16, 20. I don't see where I missed it, but I'm sure I missed one of these packets along the way. If I'd stare at it long enough, but live I can't catch it. But so we missed one packet along the way. So now let's think about the link speed. We need to know how much speed we need, and that's going to be related to the speed. Typically speaking, we're going to have a gigabit per second links. We're going to have 10 gigabit per second links, which are moderately fast links in today's world. We're going to have 100 gigabit per second links, which are going to be very fast wide area network links. And on a dedicated connection, if we buy one of these things, we're going to get about 90% of the speed. The reason I say 90 is the overhead of the TCP headers, that kind of thing, Ethernet framing, those kind of things. And the protocol will also determine. For example, TCP headers and SYNs and ACKs going back and forth takes up more bandwidth than actually UDP, just send it and hope the receiver gets it. So the protocol used will also determine the type of speeds that you're going to deal with. As I mentioned earlier, I mentioned the TCP sliding window, and keep track of this. And this is going to go into some of the things that Mo talked about earlier when he talked about congestion avoidance, and he talked about weighted random early, what do you call it? Weighted red. Can't remember what the acronym means because I was taught it as weighted red, all things. But realistically speaking, this is the way TCP is going to actually set up a connection. And this takes overhead. So if I've got someone that wants to receive something, I have to open up a connection over here, and I just have to say, open a connection. And then they have to acknowledge the connection. And then they have to open up a connection on the other side, which then gets acknowledged. So it's that three-way handshake. I actually don't like this picture. Let me try to do it in a manner that I think will help a little better than the picture that I put over there. So here's the server, and here's the user. User wants to open a connection on the server. So what it does is it sends a SYN, synchronize, open a connection on the server. The server, because it's a connection-oriented protocol, will then acknowledge that. I acknowledge that I received your SYN. Oops. I've acknowledged I've seen your SYN, and it's going to come out like it's going to send that. Ugh. It's going to send this back, and then it's going to say, but I also want to open a connection with you. So then these two messages will be sent back to the person that wants to receive it. Now at this point, the SYN or the open message was sent initially from the receiver to the sender. The sender then acknowledged the message, and then synchronized by send a message back, and the last message that needs to occur is the acknowledge needs to go to the server. And now these two are allowed to actually exchange information. That's the three-way handshake. And the sliding window, which we talked about, is the way this will also work, is the first time after we've had this set, this, let's say user. The user is going to send a file to a server. So the user sends one message, and the server says, got your message. Now, at this point, the user is going to send two messages. Why? Because this is the way TCP flow control works. So it's going to send two messages to the server. And when the server acknowledges it and says, I've got it, what's ultimately going to happen is this time, now we're going to get, let's bring it with me. Now 4 messages are going to go to the server. And they're going to be sent to the server. And assuming the server got it, the server will acknowledge it, and then 8 messages will be sent to the server. I'm just going to use 3 at this point. So now 8 will be sent. And if the server doesn't get it, this process will begin all over again until they find exactly how many messages can be sent without losing data, otherwise known as packet loss. So that was the next thing that I was going to get into. What is packet loss? Packet loss is when we lose data over a network. And typically speaking, we lose data because either there's a problem with the fiber optic connection, meaning it's not perfectly shiny or sharp, or we're losing it because there's a problem with the data link layer, maybe an imperfect card, or there's too much congestion on the line. Any of those things can cause us to have degraded network performance. Let's talk about another place where we can have degraded network performance. Oversubscription. Look, inside of my network, for the most part, I create as many networking speed, I use as many links as I need. But let's talk about what oversubscription is. Oversubscription can give us poor performance in the cloud computing, and oversubscription can give us poor performance on internet. The way the world works is, typically speaking, not everybody uses everything at the same time. So when a cloud provider is going to build their network, or an internet service provider were to build their network, if they had 1 million customers and each customer had a gigabit connection, it is unlikely that all 1 million customers would ultimately be using 100% of their gigabit connection at the same time. So what companies do is oversubscribe. So instead of having the total capacity of 1 million times 1 gigabit per second, the service provider will typically assume that 10% of their users are using their systems full time, all of the time. And they can basically build capacity for about 1/10 of what everyone is. And that's why internet bandwidth cannot be guaranteed, because all the internet service providers oversubscribe or sell more capacity than they have. Airplanes do it all the time. You show up in the airport and they're offering you money not to board the plane because they sold more seats to the plane than the plane had seats available because they knew some people wouldn't show up. Well, that's oversubscription. But this could cause a performance problem if everybody uses their traffic all at the same time and the internet service provider or the cloud provider does not have sufficient capacity. So kind of keep this in the back of your mind. You have no control once you get on the internet. And if you're using VPNs to connect to the cloud, now you know why you can't actually guarantee them. So let's talk about some other ways we can improve our network performance in AWS. So the further your stuff is from each other, the slower the performance. The closer it is, the better the performance is going to be, all things being equal. And when we're dealing with high performance computing, sometimes you want to get stuff closer to each other to reduce the latency. And that will get us closer together. I may have to sneeze, bear with me if I do. Okay, that's what happens when you love cats and you're allergic to cats, but a cat sleeps on your head every single day. You have a little bit of allergies. But as we were discussing, when you put your things closer to each other, they typically have better performance. So inside of Amazon, they give us the ability to put our stuff or our servers closer to each other. And they came up with a concept called the placement group. And all a placement group is where you're going to group your virtual machines. And that by doing so, you can determine what the latency is and you can plan around it. So if you've got a high performance computing workload, where you put your systems can be very important. So let's talk about the options we have. The highest performance option is something called a clustered placement group. And what is a clustered placement group? Well, pretty much you put all your instances as close as possible, which has got its benefits, but it's also got its risks. In many cases, a clustered placement group could have all your virtual machines in the same server. Well, what happens if the server fails completely, like a hardware fire? you got a problem. Often in a clustered placement group, all your virtual machines are in the same rack. You don't get any better performance than in the same server or in the same rack, but if the power distribution for the rack goes down, poof, the whole rack can be different from a power perspective. So cluster placement groups, really great performance. But understand in the back of your mind, if all your things are that close to each other, there's a good opportunity for things to go wrong. So here you have a visual example of a clustered placement group. In this particular use case, we've got all of our virtual machines all sitting in the same rack, all in a single availability zone. And by doing it that way, what you can see is we've got really great performance, but there's a whole lot of stuff that can go wrong. So what if we can tolerate slightly lower performance, and we don't want to be in such a risk of having everything in the same rack or the same server? Well, this brings us to the point where we can do something called a partition placement group. And what is this? Here we can spread our virtual machines and our stuff across a few racks, often in the same data center. But now instead of everything being in the same rack, it could be in the same building. Well, the reality is when you're in the same building, that's still a local area connection, you're still going to get very low latency. And now if you've got a power failure in a rack, it doesn't matter. If the switch port where the 1 or 2 servers were in that same rack were to go bad, you've got some redundancy here. So much less risk. And you're still going to get some excellent performance with less single points of failure than with the cluster placement group. And this is typically a very good option for high performance. And you can see what it looks like here. You've got virtual machines sitting on servers that are inside of 3 racks, all in the same data center, otherwise known as availability zone. And that is your partition placement group. Good performance spread across a couple of racks. Now, what if you still need relatively decent performance, but now you need a higher availability system? You still want to spread your load across hardware. And you want to spread it in a canal across racks, servers, power distribution units, but now maybe you want to split it across a data center. And if you're in a region and you've got multiple data centers, with a mile or 2 of each other, that's pretty low latency. Even if it's 5 or 10 miles from each other, that's still relatively low latency. So that's where we bring into the spread placement group. And a spread placement group is putting your virtual machines across a couple of data centers. And by doing so, you've got a lot of more protection from any kind of challenge or damage there. So let's look about what we're talking about here. So here in the spread placement group, we've placed our virtual machines in 2 different racks in availability zone 1 or data center 1, and then 3 different racks in data center 2 or availability zone 2. That's a spread placement group. This is going to give us very good performance, and it will also give us a lot better in terms of availability. Not as good a performance as with regards to a partition placement group or a cluster placement group, but much better availability. And now you know exactly where you can choose from. I want to talk about 2 more higher performance options. So anytime we talk about an EC2 instance or a virtual machine in VMware or a virtual machine in KVM or QEMU or an Azure virtual machine or a Google Compute Engine instance, it's the same thing. Basically, we've got our server, we've slapped the hypervisor on it, and now we have all software-based computers. Software-based BIOSes for the computers. Well, BIOS is always software. Software-based video cards, software-based network cards. Software. And here's the thing to remember about software. Software is slow. Software has to go to the CPU. Hardware is fast. So when the world's fastest routers, all the traffic forwarding is done, except for the first packet flow, is done in hardware and not software, because hardware or ASICs can do things much better. Now we enter the world of what kind of network support do we want in our virtual machines. And we can enter the world of hardware network cards or software network cards. So When we need a higher performance network interface, we have two choices. One will be something called single root IO virtualization, and the other will be called virtual fabric adapter, and I will talk about it. And I did not make the term single root IO virtualization. Here's what it means. You've got a virtual machine, you push through the PCI interface of the server, the network card into that virtual machine, and now you've got a hardware network card. Now you've got good network. For any of you that have an interest in machine learning and artificial intelligence, a lot of the computing is done on GPUs. Not all of it. It can be done on a TPU, a CPU, an ASIC, but a lot of it is done on GPUs. Now, when you're in cloud computing and you want to rent a server with a bunch of GPUs, does that mean it's a bare metal server and only you can access it? No, they're virtual servers. So the way we actually use GPU-enabled instances or GPU virtual machines is they physically push through the PCI interface a GPU into the virtual machine. That's how you can have high graphics performance in a virtual machine, not software graphics performance. It's the same thing. It uses a technology called PCI pass-through to push a hardware card into a virtual machine. And that's now what single root IO virtualization is, hardware-based networking in your software-based virtual machine. Now, while we're at it, AWS actually made a very high-speed software-based network adapter and driver that can offer very high performance, up to 400 gigabits per second. At least that's what the spec is designed for, though we've not gotten there yet. I think we've reached the end of my content, and Benedict is going to have some more things to discuss with you very soon. So let's come back. Let's see if you've got any type of questions before we go to the next one. And then we'll get to the next content. I know Benedict's got a lot of great things to talk about. Okay, do you have any questions for us? And yes, thank you, Kenter. I was definitely sneezing there. Kenter Grant, I wish you could smash that like button a million times. That would be so nice, and I so appreciate it. This content, and you guys are awesome. Thank you, Kenter Grant. We work very hard to try and make sure we can provide as much training as we can for the community, and I'm very grateful for your comment. Who's next?
I believe I am next.
Okay.
Or you mean a question?
So yeah, I actually meant that next, but yeah. So is an availability set in Azure the same as a cluster placement group? I don't believe so. I believe in availability set, and I actually have to keep track. Hold on, I can tell you what it is if I just look at the name of it. I'm pretty sure it's a set of virtual machines that one takes over after another. Yeah, no, availability sets are groupings of virtual machines to reduce the chance of something being brought down.
So it's like the cluster set or whatever.
Yes. And it can do it in they typically put it in fault domains. So the cluster placement groups are automatically trying to find a way to bring it closer together in some way to reduce performance. And an availability set is more spreading them apart, farther apart for availability. Okay, so Benedict, over to you.
Thanks, Mike. All right, so following off from where Mike stopped, let's look at some more techniques you can use to improve network performance in the cloud. So he spoke about using the fabric adapter interface. So the kind of network interfaces you use for your instances also goes a long way in determining how fast that communication can happen with those instances, right? So we have an elastic network adapter. It's a type of interface that you could deploy for EC2 instances. And it has a high performance in the sense that it gives you up to 100 gigs throughput, right? So that's something you might want to keep at the back of your mind when trying to determine the network interface to use for a critical device that needs, high throughput, right? Of course, he also spoke about the elastic fabric adapter, which provides ultra low latency and high bandwidth communication between instances in a clustered environment. Now, there's another technique that we can use to improve performance of the network in the cloud. And it's a technique that we also use on Prime, but one that you can explore if you're looking for a solution to improve the network performance in the cloud. And that is using caching and compression. So what exactly are these terms? Now, compression is a process of reducing the size of data, right? So for example, you have a video that is 2 gig, right? You can compress it and reduce the size to 1 gig. Of course, the graphics will be reduced, but if you do not mind reduction of the graphics and your priority is just to improve the flow of that video over your infrastructure, then you can employ caching as a technique to improve network performance. So when you you can employ compression, right, to improve network performance. So when you compress a file, all right, the bandwidth and storage requirements are reduced for that file. So it reduces the time it takes for the file to be transmitted over the cloud. The second term, the caching. I know we spoke about caching when we talked about the content delivery network. So it's the process of storing frequently accessed data in a fast and convenient location, typically at the edge of your network. So if there's a frequently accessed data, right, from your database servers, right, you don't want requests from end users traversing your cloud infrastructure all the time to get that same information, right? You can put it at your edge and it saves the bandwidth for your internal communication. So we typically use caching for static content, right? If you have content that is rapidly changing, for example, you have Amazon, right, .com, and people going to purchase items from different merchants. So a merchant might update the price of an item, right, on his website. And if that information is cached, it means the end user will not get the real-time data, the current price, right? So you don't want to cache that kind of information. So we have to be careful when we're planning our caching and compression strategies. Now, in order to accurately evaluate the impact of the compression and caching on network performance, you should be able to measure key metrics like Mike mentioned, latency, jitter, and the rest of them. So you measure before you compress and cache, and then after compressing and caching, you measure again to see the effect of your caching and compression strategy. So it helps you to, it's like a workaround to improve the network performance in your cloud infrastructure. Now let's talk about network topology mapping, right? And it also could be overlooked sometimes, but it's an important part of the network architecture to have basically a network diagram. So a network topology just describes the physical and logical configuration of nodes, right, in a network, right? The topology mapping now is representing all these nodes in a graphical or pictorial format, right? So you want to have that overview, graphical or pictorial overview of all the nodes in your cloud infrastructure. And why is it important? So you can see where there are potential bottlenecks in your infrastructure and then make corrections to improve the network performance, right? And in AWS, we have the AWS Network Manager that you can use to perform this topology mapping as observed on their topology graph page. So it's pretty important that you have that pictorial overview of your network, right? So on-prem, we have various solutions that can, draw that graph of your network and give you an idea of what's going on. OP Manager is one of them. You have the Cisco Network Assistant, Manage Engine, and of course, you can use some of these solutions in the cloud. You just have to install the software on a virtual machine on an EC2 instance and then use that to plot the map of your network. Now let's talk about the AWS EventBridge, right? EventBridge is a service that provides real-time access to data changes in AWS services, right? So you want to be aware of what is going on in your network, and EventBridge is a solution that gives you that capability. So what's going on is that it's monitoring the services, and if there are changes, data changes in the services, then it alerts you so you can, monitor the network, right? So if you have an S3 bucket, for example, and someone goes there and deletes a file, right? EventBridge can send you that information in real time, all right, that such file has been deleted, and you can go in there and make sure everything is working okay. So EventBridge is also useful in that it allows you to build event-driven applications. Remember, we spoke about event-driven automation. So if this data is deleted, then what happens? Do this, right? So that service can help you to achieve that aim of having an event-driven network architecture. Now, there are some key features of the AWS EventBridge. And one of that is events. And events are basically any real-time change in a system or environment or data. So going back to that example, if your file is deleted, that's an event, right? And then we have event sources, which are used to ingest events from applications into an AWS customer account. Then we have the event bus, which is like a virtual router that receives events and delivers them to destinations. We have rules, which are sets of instructions created and associated with an event bus to match certain events. And then we have the targets that process events and also can include AWS services such as Lambda functions and kinetic streams. So how exactly does EventBridge work? So when your resources change state, they automatically send events to an event stream, right? And then you can create a set of rules that match selected events in the stream and then route them to additional targets to take action. So for example, if a file is deleted, you create a rule that if a file is deleted, then send this event to this target to restore the file, right? Send this event to this target to restore the file. That's a rule that you've created. And each rule is associated with an event bus, all right, so that it can work with delivering the events to the targets. And some of the benefits of the EventBridge is that it helps to allow you build event-driven architectures, because real-time data changes is enabled. It has security features. It can integrate with AWS Identity and Access Management Services and the AWS Key Management Services as well. And then you can filter events, allowing you to control what events to target. So you don't just want a flurry of events to trigger alerts, right? So you can be specific as to what you want to monitor with EventBridge. So EventBridge integrates with CloudWatch and AWS X-Ray, which we'll look at later, making it to monitor and observe the performance of your events-driven applications. Now, there was a question on YouTube about how we can effectively carry out network troubleshooting, right? So we want to talk about network troubleshooting next. And when you are dealing with networks, there will always be problems, right? Things will always go wrong. You cannot have a network running smoothly for infinity, right? So when these issues happen on the network, we should be able to have a systematic approach to troubleshoot the network problem and fix them. So take, for example, your direct connection, right, from your office to the cloud, right? If there's a failure on that logical link from your office to the cloud, where do you start looking? From? Recall there's a router in your data center, right, where your service provider will terminate the direct connection to the cloud. So you want to check the router. It's called the customer premises equipment router in your data center. You want to check with the service provider to see if they have any outage on their infrastructure. You want to look at the router and the switch ports in the direct connection location. Even if you don't have access to that location, you can work with your service provider to troubleshoot the devices there and isolate the problems. It could also be a configuration problem in the cloud. So, I mean, working from the customer end to the cloud helps you to build a systematic approach to network troubleshooting. So when you find where the communication is broken, you can easily fix it and get your connection back online. Now, generally, when performing network troubleshooting, we have different phases. And the first phase for most people will be to test for connectivity, right? So for example, if you have a website that is down, right, you want to see if the server that hosts that website is reachable, if it's still online. And we use the ICMP protocol to test for this connectivity, right? So you can use your ping requests or your trace routes, pinging from one location, your office location, to the server, or from an EC2 instance to the server IP address, right? So you start at that level, start with that connectivity test, right? Now, if you get a reply from the server, then you know that the problem is not with reachability to the server. What you want to check next is the DNS name, right? So the server is going to have a DNS name. www.bbc.com is tied to an IP address. So if pinged the IP address of bbc.com is reachable, You want to ping the DNS name, ping bbc.com to see if it's response, right? This is the next level of troubleshooting. If you do not get a reply from the IP address or from the DNS name of that server, then you want to be looking at the subnet level or the router level, right? So the router is probably the default gateway of the server. So you want to check to see if that router is up and running and everything is fine. You want to see if other servers in that subnet are up and running. So you do a ping or traceroute test to other servers in that subnet to see if you get a response, right? Now, if you get a response from the router, then it means that the router is fine. You can now move on to the next phase of your troubleshooting. You log into the router and try to ping the server from the router, right? So you're moving your troubleshooting step now from closer to the server, right? You've tried remotely, you can't reach. Now you're trying from the server, trying from the router, which is closer to the server, and to see if you can reach the server or if there's something blocking the server. Now, if you get a reply from the router to the server, then you know that your connection is probably broken from yourself to that router, and then you begin some extended troubleshooting on that leg of the network to see what the problem is. Now, if you can get to the router and the router cannot get to the server itself, it means there's a problem, probably from the server itself. So you want to log into the server and review the host-based firewall there to see if it's been configured to drop some traffic. You want to review the security group which protects that instance, that server, to see that all the inbound and outbound rules are correct. You also want to review the network access list attached to that subnet where the server is connected. Is it too restrictive, which is preventing this normal communication? Or is there a problem with CPU utilization on the server that it cannot respond to requests anymore? So these are some troubleshooting steps that you want to look into in the phase one. Now, phase two of your network troubleshooting will be to identify where the traffic is stopping, right? Or where the traffic is getting lost. So we use the traceroute command, which also uses the ICMP protocol to carry out this function. So from your PC or from your instance or wherever you're doing the connectivity test from, you want to run a traceroute to the IP address of the server, and then it will traverse multiple hubs and then stop at where the problem is, right? So if the problem is at a router in your network, you see that after it hits that router, it begins to not respond anymore, right? You don't see any hops after that. So you kind of figure out that is where the problem is coming from, and then you log into that device and continue your troubleshooting from there. Now, take note that with the ICMP protocol, there are many firewalls, right, that might be in the path of your connectivity to the server, and firewalls by default will drop the ICMP protocol except it is allowed otherwise. So it could be a red herring if you see your traceroute dropping at an IP address. It might just be a firewall there that's dropping ICMP, and that might not actually be where the problem is coming from. Then we want to move on to phase 3 of the network troubleshooting. And that is where you actually isolate the issue. So you've done your trace route now, and you've seen where it's dropping. It's dropping at a particular IP address, and you've identified that that IP address is a router. So you can then log into this router and then check the routes to the firewall, so the routes to the server, and see if there's a route allowing return traffic. Check if there's spanning tree loops and stuff like that. Spanning tree will be on a switch, but on a router, you want to look for routing loops and access lists that are too restrictive. So it's really beyond the scope of the AWS exam to go in depth into troubleshooting, but these are some basic steps you can take when troubleshooting your network. Of course, you want to use CloudWatch as well, right, to monitor activities going on with your instances and stuff like that. Now, another tool that is great for troubleshooting in AWS is what we call the route analyzer or the route analyzer, if you're British. It's a troubleshooting tool that we use to perform analysis of the routes in your transit gateway routing table. So take note of that. It looks for analysis of the routes in your transit gateway routing table. So if you have a transit gateway that is interconnecting your branches and your AWS infrastructure, you want to use the route analyzer to check for any connectivity problems if you can reach AWS from one of the offices. So how does it work? It actually looks at the routing path between a source and a destination. So a source should be a branch office, and the destination will probably be the AWS infrastructure. So it analyzes that route, right? Looking at the path that the source you use to get to the destination, and then it will give you information about the connectivity between those components. So if you want to use the route analyzer, all you need to do is to specify the source and destination IP address. So the source IP will probably be an IP address in your office. Destination IP address will probably be a server in the cloud. You just specify that in the route analyzer, and then click run the route analyzer, and it will give you the results. So it's good for validating existing routing configurations and finding routing problems that could be disruptive to your transit gateway global network. Another important tool that is available for troubleshooting in the AWS cloud is the Reachability Analyzer. And this one now is a tool that is used to analyze the path between a source and a destination in the cloud, right? So if you have an instance if you're trying to verify connectivity between an instance and a database server in the cloud, you want to use the Reachability Analyzer to, simulate this traffic flow and see where the problem lies if there's no connectivity. So how does it work? It builds a model of the network configuration, and then it uses that model to check for reachability based on the configuration, right? So it's just looking at the configuration, and then once you put the source and destination, then it looks at your routing table, looks at the security groups, looks at the network access list, and it uses that information to determine whether there'll be reachability issues between that source and the destination, right? So you can specify source IP, destination IP, and port number, right? So if it's a web server, you can specify the IP address of the server and the port number. So it just filters your troubleshooting to HTTPS and ignores every other thing, right? Now, if there are multiple paths between a source and a destination, it will usually choose the shortest path and run the test on that path. So the good thing about the reachability analyzer is that if there's a problem of the source getting to a destination, maybe an EC2 instance getting to a database server, it will usually tell you the component that is blocking that path, right? So it saves you more troubleshooting time by pointing you in the right direction. Now let's talk about using packet sniffers and protocol analyzer. So I'm sure that many of you are familiar with Wireshark, right? And many firewalls, next generation firewalls, also have inbuilt in them a solution to perform packet sniffing, right? So that you can easily solve connectivity problems. Now, packet sniffers and protocol analyzers are very useful tools in helping you analyze the flow of traffic and then showing you where there are potential problems, right? You can use it to do much more, but they are helpful in that regard as well. So if you're able to reach, for example, the subnets where a server is deployed, but you cannot reach that server itself, right? You could run a protocol analyzer, which will capture the packets and then show you where the packets are being dropped, right? So it helps you to further narrow down on the potential bottlenecks for in your network troubleshooting. It could be a security group that's dropping the file or dropping the traffic, or a host-based firewall. The protocol analyzer will usually tell you what the problem is. Or it could just be the handshake not concluding properly because of one or more problems on the server side. Now, in your data center on-prem, it's easy to use a protocol analyzer to capture traffic and then analyze and fix problems. But in the cloud, it's a little bit tricky, right? So in order to be able to achieve this on the cloud, what you do is to spin up a server, a virtual machine, right? That's an EC2 instance, and then install the protocol analyzer there on it. And then from there, you can launch the protocol analyzer and then capture traffic that is coming into that subnet, right? So you can install Wireshark on an EC2 instance and then use that for your troubleshooting. VPC flow logs are also good as well. So they give you an idea of what's going on your network, right? After the fact. So I believe we can take some questions now. Before Mike will go ahead and talk a little bit about CloudWatch.
Absolutely. You can happily answer some questions. Use cases for the Elastic Network Adapter and Elastic Fabric Adapter. So I talked about the single root IO virtualization being used for high performance networking because it's a physical card versus a virtual card. And the Elastic Fabric Adapter is for really high performance computing. It's a software-based driver. Either of you want to add to that at all?
Well, if I have a storage compartment that needs to receive large amounts of data at every specific points in time, right? Like a data warehouse or stuff like that, receiving high volumes of traffic, then I'll probably want to use an adapter for that instance that can give me above 100 gigs throughput of bandwidth. So that will be a use case for this kind of adapters.
So basically for elastic fabric adapter for high performance and high network performance, right?
Yeah. Monkey Jung is asking, what technique or processes do you use to troubleshoot network issues that brings down a website? So we spoke about a couple of things that you can do using ICMP protocol, ping trace routes to do connectivity tests, using your reachability analyzer to test reachability from one location to the other. You probably have CloudWatch in there that is receiving events from your website, and you can go to the CloudWatch to get more information about the logs from this website, and that will aid your troubleshooting. EventBridge, I also spoke about the EventBridge service that can send you real-time data of stuff that is going on in your infrastructure. So these are some services you can use to troubleshoot issues with your website.
Yeah, I would say that if you already know it's a network issue that brought the website down, then you're very close to finding the issue, right? Usually when the software team or development team, whatever, says the website is down, you want to first ask, like, how do you know it's a network issue, right? Like, what do you have? Can you give me what errors are you seeing, right? Can you look at the logs and see the error, right? Is it DNS? Is it IP, right? And then once we find that out, you want to trace it down to find where the error is, right? Of course, if you have multiple teams working at the same time to find the issue, then I would say as a network, from the network team perspective, we always like to start from layer 1, move it up, right? So having more of a systemic approach, or for troubleshooting, right? You start from layer 1 and move up, right? You don't want to just be all over the place, and doing things from different places. But just like Benedict said, there's a lot of tools that can help you. But I think you always start, when there's an issue, start with, investigate what that team says, right? What's the issue? If they can provide you logs, that will help you understand what the issue is, right? It could be anything from DNS to certificates to power issue, maybe, right? So really, it's like, that's why we like to start. You want to have a consistent process, right? And I think starting from layer 1 and moving up is the most consistent way to do this.
Yeah.
So Omar is asking, what sort of event can we set if an EC2 instance CPU usage is 100%? Well, so the first thing I'll do is that I won't create an alert to tell me when my CPU is 100%, or probably when it's 80% or 70% that I want to receive the alert.
Yeah.
And then you can create that alert in CloudWatch, right, to send you an email when that, or an SMS when that utilization hits that range.
And you want to set up alerts long before they get to 100. And then much more frequent alerts once they hit 90, because if your servers are sized properly, they shouldn't be getting that high.
Yeah.
And if I'll let you guys answer this, the difference between transit gateway and direct connect gateway.
Yeah. So a transit gateway is a resource that allows you to connect multiple VPCs together, right? So allows you to have different VPCs connected to each other, right? You can have more of a hub and spoke setup rather than a full mesh where each VPC needs a direct connection to other VPCs, right? And of course, think of the transit gateway as a router because there's so many different setups you can do with a transit gateway, right? You can also set up VPN tunnels, right? Site-to-site VPN tunnels to your on-premises with the transit gateway. You can set up multiple routing tables, or think of it as separating that one transit gateway into logical routers, right? Instead of one or multiple transit gateways. So there's a lot of different setups you can do, but think of it mainly as a method to establish VPN tunnels and to connect VPCs to each other. Direct Connect Gateway, on the other hand, attaches only to one VPC, and then from that VPC, then that Direct Connect Gateway, my apologies. I said direct, I was thinking of a virtual private gateway. So a Direct Connect Gateway is used to establish private lines. So you use a Direct Connect Gateway to establish private lines or connect to your on-premises, right? And so once you have that connection from the Direct Connect Gateway to your on-premises, then you can utilize that connection by connecting that Direct Connect Gateway to your VPC, right? So completely different, two different products or solutions that provide, give you different connections, right? So think of Direct Connect Gateway for Direct Connect connections or private lines, and a transit gateway to connect your VPCs. I think that's the simplest solution answer.
Mike, your question did not show up here. I explained federation. Thank you. What is synchronization? So federation is really how you're going to create secure IAM environments by tying your cloud provider's IAM into an identity provider. Synchronization is when you take two IAM systems and you synchronize them so they maintain the same users, the same groups on both. Generally speaking, for high security environments, we use federated identity and access management. Can't think of why you wouldn't want to do that, but from a complexity perspective, but that would be what your synchronization is. It's a good question.
So can we use one transit gateway as a hub to serve many VPCs? Yes, that's exactly what you do. That's the main benefit of a transit gateway, right? It's the hub to serve multiple VPCs. Not only that, you can use the transit gateway to connect to other transit gateways, right? So let's say you have multiple VPCs in one region and other VPCs in another region, right? You have one transit gateway in each site, in each region, and then you peer between those two transit gateways, and now you have access, between those regions.
All right.
Then can a transit gateway connect VPCs in different? That's exactly, I pretty much answered the question by chance.
So this is a great question from Samsung. What's the real difference in responsibilities between a senior architect and a principal architect? It can be a little or a lot, and I'll give you, and there's typically $100,000 to $200,000 difference between these roles as well. So a principal architect is someone that's made it, meaning they're now no longer focusing on, trying to figure out what an architect is, not stuck between an engineer and an architect. You're dealing with a business executive that really understands the client. They've got really good communication skills and really good leadership skills. They typically know one thing and know it fairly well, but it's all about relationships. So it's getting further and further away. So instead of having a direct client, you typically get brought in to help other clients. 99% of my career was as a principal architect. So I was the architect that the architects would call. I was also the architect when there was a $1 billion deal. Go bring in that principal architect. They know what to say to the customer, talk to the customer, show our strengths, and make us look really good. A senior architect could be that good. They really could be. Or quite honestly, some of the people I've trained, I've got several students who are senior architects as their first architect job, and they came from another field. And they could still be great with no background. At the senior level, you're still figuring out your architecture journey. you haven't quite figured out exactly how to get to the top, or you already would be there. And typically at the senior architect level, the people are still focusing a little more on the tech and a little focus on the business. But I got to tell you this, Samsung, when you're an architect and you get the right business acumen, the right leadership, and the right executive presence, you go from architect to principal architect real fast. I did it in 2 years, where it typically takes people, 10 or 15 years that are focused on the tech. So focused on making your customers successful, focus more on those business outcomes, focus more on those business processes, focus more on quantifying the value you're giving your clients, and you'll be a principal architect. And it's going to be a little further away from the technology. It's going to be a lot closer to the business, and it's going to pay a lot more. You'll get a lot of respect too. It's a wonderful job. And honestly, Samsung, I'm going to have that How to Get Your First Cloud Architect Job webinar on Thursday next week. Come to it. There'll be probably a couple of principal architects that I know real well that'll be on that call as well, or people that had one of those on their roles on the way to the top. So let's talk about CloudWatch. And CloudWatch, realistically speaking, is a monitoring service that's going to monitor your AWS resources and the applications you deploy on AWS. And Benedict got pretty deep in some of these things, so I'll talk more from an architecture perspective. CloudWatch is going to give us some metrics to look for things. So that CPU that's using too much CPU, running low on memory. Are we running low on memory? Do we have a memory leak? Do we need to reboot the server? Do we need the application people need to fix that memory leak? So these are the kind of things that we're looking for. The key with CloudWatch is you can collect your information, you monitor it, you can act on it, you can analyze on it. So that's really what we're talking about with regards to initially what it is. It's a logging service. So CloudWatch is going to have a couple of built-in default metrics. Not a lot. Your CPU utilization, your disk read write, basically in terms of input and output operations that's going on, and your network utilization. So not that much. Now you can set up custom metrics to actually learn more what you might need to be going on. So here's the thing. We might need to check our memory utilization. We may need to check our AP5 performance and other metrics. And CloudWatch is really a notification system that's going to enable customers and allow them to set events when they reach a certain threshold. And that's the key. Those CloudWatch events, that EventBridge kind of stuff, really gives us the ability to do those event-driven things, which is what Benedict had talked about. Trigger auto scaling, a Lambda function, that sort of thing. Now with CloudWatch, we're going to have two monitoring options we can use. We can use the basic monitoring, which is the default. Your data is available every 5 minutes and they don't charge you. And detailed monitoring is if we're going to be able to monitor anything significant, we're going to want to turn on detailed monitoring and we're going to pay for it. But it's typically available once a minute. Benedict talked a fair amount about EventBridge and CloudWatch events. I'm just going to talk about it a little bit. CloudWatch events is going to give you a near real-time stream of things that are going on. And you can set up those rules and something happens, do something else, those event-driven architectures. And honestly, CloudWatch events and that EventBridge kind of concept and automation is really great. And because CloudWatch events will be aware of any kind of operational change when it occurs. And it can respond to these events and take action. So these things tend to be pretty important. Now, let's talk about logging. So it's a certification exam. So here's the thing to think about. CloudWatch, monitoring, CloudTrail, logging, auditing. So CloudWatch is monitoring and logging, CloudTrail is your audit. So for your compliance things, you're going to have to go back and you're going to do an audit. You're going to go to CloudTrail. And that's an AWS service that's going to keep track of things, which is going to help you with audits. And it's going to basically give you an audit trail. And when it comes to risk management, you've got your audit trail, who did what, when, how, why, that kind of thing. Compliance, great. And if you're in a regulated industry like banking or healthcare, this matters so much more. So CloudTrail will track the changes that are made and can track it to the user, the role, or even if a service role, like if one of the systems made a change to another system. Now, CloudTrail is going to be enabled when your AWS account is enabled and created. And to start it, all you'll have to do is click Start a Trail, or create a trail in the CloudWatch console. You can also do it with the CLI or the CloudTrail API. and it will record every event as they occur. So CloudTrail is going to give you an event history. And by default, it's going to give you a history that has occurred in the last 90 days, which is great. 90 days gives you a long window to go back and see what kind of stuff happened. But what if you're in a highly regulated industry and you need to go back 6 months, 9 months, a year, 2 years? Well, we can do that too. And you might need to do that. And it's probably a best practice to store your information for a period of time anyway. So what you can do is you can set up CloudTrail to send your logs to object storage, otherwise known as S3. And by doing, you can keep it for long-term storage. You can back up your logs, archive your logs, whatever you want to do. When it comes to CloudTrail, there's basically two kinds of trails that can be created. A trail that is local to one region, and that's going to be the default, and it's going to be what you're initially going to do, and it's going to store your CloudWatch logs into a single bucket, default option, if you configure it by the command line interface of the API. But you could also configure a trail that applies to all regions. And that's going to give you your most comprehensive logging and auditing options. It's going to provide a record of all events that occur outside your organization's infrastructure. And it can help correlate events across organizations and the global infrastructure to give you insight on fixing problems. So at this point, Benedict's got lots of things to talk about the Transit Gateway Network Manager. So we'll come back. And Benedict will talk, and then I think after Benedict's discussion, we should probably go to some questions.
Yes, Mike, thank you for introducing monitoring and logging with CloudWatch and CloudTrail. I actually delved deeper in monitoring and logging. So the first other monitoring option we have here is the Transit Gateway Network Manager. And it's a network management tool that provides a comprehensive view of your interconnected AWS transit gateways. So just like CloudWatch gives you an overview of the instances and applications running your system, the Transit Gateway Network Manager gives you an overview of your transit gateway and the different branches and their interconnectivity statuses as well, right? So how does it work? You have to register your AWS transit gateways to the Transit Gateway Network Manager, as well as your on-premise locations, right? So once you register them to the Transit Gateway Network Manager, you are able to have a centralized dashboard to monitor your transit gateway services, right? So it's useful to organizations because it gives you that centralized network monitoring, gives you global network visibility, gives you a unified interface to manage your global network. I mean, you could just have a screen dedicated in your office with the Transit Gateway Network Manager just to show you that everything is working smoothly, right? Another tool that we use for monitoring in AWS is the VPC traffic mirroring, right? And this is similar to what we've come to know as the span ports when we're dealing with switches on-prem. So the VPC traffic mirroring, right, is a feature that allows you to capture network traffic at scale, right? So you want to capture all the traffic coming into your VPC, right? But you don't want to disrupt it, right? So that's the essence of how a span ports work. You just mirror that traffic to another port and then capture the traffic from there, right? So it doesn't affect operations of your infrastructure. So what happens basically is that network traffic from the Elastic Network Interface is copied and then forwarded to another port where you can now analyze the data and do whatever you want with it. So traffic mirroring allows you to capture traffic in real time and analyze it without impacting the performance of your infrastructure. It also supports packet filtering, so you can mirror the traffic to another port and say you only want to capture traffic going to DNS services, port 53, for example, right? So you can filter it down in that way, which is quite useful. Now, how does the VPC traffic mirroring works, right? There are some key terms associated with the traffic mirroring. The first one is that there's a source, and the source is the EC2 traffic to be mirrored or captured, right? Then there's a target, and the target is the instance which will capture the port, which will capture the traffic. So you're capturing the traffic from an EC2 instance and sending it to a target, which is another EC2 instance. You're sending it to the network interface of that EC2 instance, right? And then you have the mirror session, which is the procedure to start directing source traffic to the target. Now, in order to get traffic mirroring working, right, you have to designate a source EC2 instance and a target EC2 instance. So when you specify this source and target EC2 instances, and then you start your mirroring session, it's going to capture the traffic that is going to the source EC2 instance and then mirror it to the interface of the target EC2 instance. So I have a diagram here that can throw more light on the operations of the VPC traffic mirroring. All right, so you see in the diagram here that you have two instances, right? There's a source instance on the left, and there's a target instance on the right. And you want to mirror the traffic going to this source instance to this other, the target instance. So as traffic is coming in, as network traffic is coming to the network interface of the source EC2 instance, you just mirror the traffic, right? And copy and forward it, right? You mirror it to the network interface of the target. And then from this target, you can now run your analysis and, do your intelligence, artificial intelligence, and whatever you want to do with that data. So that's how it works basically. And like I said, it's similar to the span ports we use on-prem. Now, why would you want to use traffic mirroring? Well, it's useful as a detective tool to find network and security anomalies, right? So if the server has been having a lot of network attacks, you can mirror the traffic going to the server, the source EC2 instance of the target, and then analyze it there to see if there are malicious bits of traffic going to that server. Then you can take steps to mitigate. So it's helpful for security in that regard. Now, it also helps you to gain operational insights, right, into the network traffic coming into your instances, which will help you to make better decisions. Now, there are some regulatory and compliance requirements that mandates that you must monitor and log all network traffic, right? So that, of course, they can go back and do that audit trail or CloudTrail when there's an incident. So the traffic mirroring helps to fulfill these regulatory and compliance requirements, because you're capturing all the traffic and sending it to another instance. So you're logging that traffic, right, in raw form. And it's a very useful troubleshooting tool to help you analyze traffic patterns and see if there's a need to, add resources to that server to cater for an increase in network traffic, or just plan your network infrastructure better. Now, Mike spoke about CloudTrail and how it helps to gather logs for different instances in the cloud. We want to take a deeper look at logs, right? And logs are very important because they kind of tell you what is going on in your infrastructure. So you're not blind to its operations, right? So you want to have that after the fact view of what's going on so that you can improve the performance of your infrastructure or solve problems or potential problems, right? Now, Mike mentioned that CloudWatch is a source of logs, right? You can send logs to CloudWatch, and then from there you can analyze it. There's also the syslog service, right, that you can use to capture logs from different applications or different instances in the cloud, right? So that's also an option to collect logs, syslog. Now, in AWS, we have different kind of logs that can throw more light on the operations of your services in the cloud. The first kind of logging we want to talk about is the transit gateway logging. Now, we've already said that the transit gateway allows you to build a hub and spoke, right, architecture in the cloud. So your branches to your AWS infrastructure. But you want to be able to monitor the traffic or the activities that is ongoing in this hub and spoke technology. So the transit gateway gives you some form of logging so that you can identify what is going on and solve problems and make improvements. So transit gateway logs are detailed information, including the source and destination IP addresses, the port numbers, the protocol type, the timestamps, and collection of metadata, right, on network flows across the transit gateway, right? So logging information is found in the flow logs for transit gateways. I have a picture here of what the transit gateway logs look like, and I'll just share my screen so you can see. So you can see that you can get information such as the interface where data is emanating from or coming to in the instance on the cloud. You have the source IP address, you have the source port, right? You have the protocol, number of packets that has been received. You have destination IP, destination ports, number of bytes that's been sent across this transit gateway, the time that the traffic started and stopped, whether the traffic was accepted or rejected. So, I mean, it gives you some very important information that you want to have as an administrator of the cloud infrastructure. Then next, we'll talk about the load balancer access logs. So, of course, we know the function that a load balancer performs. It receives requests from users and then sends that request to backend servers based on an algorithm. Could be least privilege, could be round robin, so and so forth. So it's a good idea to have visibility into the traffic received by the load balancer and sent to the server, right? So it gives you an idea of what's going on in that system, right? So in load balancer access logs, you would usually find information such as timestamps, that the time when the request was received, the client's IP address, latency, server responsive, responses, and stuff like that, right? But in order to get it working, you have to enable login on the load balancer because it's disabled by default, right? You have to enable the access logs on the load balancer, and then it will ask you to choose a location where you want to store the logs. So at that point, you can then choose an S3 bucket, right, where you want to store the load balancer access logs, right? Now, you have to keep in mind that the health checks requests from the load balancer to the backend servers are not included in the log. So that's something you have to keep at the back of your mind. So they are useful because it helps organizations to analyze traffic patterns and troubleshoot issues, right? Now, you have to be aware that the S3 bucket you are creating for storing your load balancer logs, you have to pay for it. So that's something you have to keep at the back of your mind and, look at when you are setting up login for the load balancer access log. So I have a demonstration here, or a picture here of what a load balancer access logs look like. So if you look at the log now, it's capturing a request to an AWS Elastic Load Balancer. So it tells you, first of all, that this is a HTTPS request, right? So this is probably a web server from indications or some other services that uses port 443. It shows you the timestamp, right? The date and time when this request was sent. You see the name of the load balancer, the DNS ID. You see information regarding the source IP address. You see information regarding the source port number. You can see destination IP address, destination port number, and other information. So this is probably, load balancer is probably looking at 200 on the backend server, stuff like that. So it can give you some pretty interesting information from a load balancer perspective, whether it's forwarding the request or dropping it, and stuff like that. So yeah, pretty cool log to have as well when you're working with load balancers. Now, how about DNS Route 53? So DNS, it's important that you are able to capture DNS queries, right, that are received by Route 53, because you want to see information such as date and time of the request, once again, timestamp, the DNS record type, is this an A record, a text record, a CNAME record, the domain being requested or the subdomain requested, right? This information could be very useful to help the server owners plan for their services, right? Now, for you to get this working, you have to configure Route 53 for login, right? Then it asks you where you want to send the logs to. You can send the logs to CloudWatch. So when you enable login on the Route 53, then you select CloudWatch as the login platform. So it begins to send the logs to CloudWatch. You can now access the logs directly from CloudWatch. CloudWatch would store the DNS query logs indefinitely by default, right? But you can configure a retention period so that older logs are deleted if you want, right? So you can have a retention period of 90 days, for example, and then after 90 days, it now begins to overwrite the initial set of Route 53 logs that came into CloudWatch. You also have the option to export the DNS queries, right, to an S3 bucket. If you don't want to use CloudWatch, right, to view these logs and analyze the data. Yeah, there's also an option to use CloudWatch metrics, right, which will just show you the total number of DNS queries that Route 53 responds to. So it's not as detailed. It doesn't give you stuff like timestamps or whether it's an A record or not. It just gives you basic metric like the amount of DNS queries I received, right? So that option is also available if you do not need detailed DNS logs. And as usual, I have an example of a DNS log, which I'd like to share with you. So here we see an example of a DNS query log or some DNS query logs, right? So you see the timestamp, right, which is very important. So you can correlate when Route 53 is receiving these queries, right? You see the time and the date here. We see the domain that it's querying. So it's going to example.com, right? The first one is an A record. The protocol here is UDP. I'm guessing UDP 53. And we see the region and the source IP address, right? You can see that this one is a text record. This one is an A record, AAA record. So you can get some pretty interesting information from here and then do some analysis on the data that you've captured. Now, how about CloudFront? Yeah, you have the option to get detailed logs from CloudFront, right? And this is basically capturing data about the users, right? User requests coming into CloudFront. You want to be able to capture that data. For example, if you have a geo-blocking policy on CloudFront to deny Canada from accessing your website, you want to be able to look at your logs and make sure that you can see deny entries from IP addresses coming from Canada, right? So CloudFront logs are important in that regard. So when CloudFront receives a request from a user, it routes the request to an appropriate edge location, right? Then it writes the data about that request in a log file specific to that edge locations. The log files are saved in an S3 bucket. And you have to specify that S3 bucket when you enable login on your CloudFront. So you can create the S3 bucket ahead of time. And then when you are enabling login on CloudFront, you just select that specific S3 bucket that you've created for this purpose. Now, CloudFront does not automatically delete log files, right, from your S3 bucket. So you can go in and do it manually to delete older files, right? Or you could use automation and use an API to delete older files after a retention period. They are useful, like I said, because they help organizations to monitor and analyze user requests. So in the previous example I gave, if you have a geo-blocking policy, you want to make sure that it's working and preventing users from accessing your content from a specific geographic location. Now, let's talk about implementing log delivery solutions. Now, if you want to implement a log delivery solution, the first thing you have to do is to identify which logs you want to collect. So do you want to collect Route 53 logs? Do you want to collect load balancer access logs? Do you want to collect EC2 instances logs, right? And then you now move on to the next phase, which is that you choose a log connection method that best meets your requirements. You can collect all those logs in CloudWatch. You could use a SIEM solution to collect your logs, or you could collect your log with a syslog server, right? Then you want to determine how long these logs will be kept in that collection platform, which I just spoke about. So you want to determine a retention period, and that will probably be driven by the policy of the organization. So if the organization says we keep logs for 1 year, for 3 months, right, that will determine how much time you set for your retention period in your infrastructure. You could also define access policies for your log data. So it's important that you control who has access to your logs. Not everybody should have access to your logs, because someone can delete logs mistakenly or on purpose, right? So you want to use some form of identity and access management process to control who has access to your logs and what permissions they have. And then you test your log delivery architecture to make sure your logs are reporting correctly, and then you can analyze your logs. Now, that brings us to another important AWS service, which is called the Amazon X-Ray. Now, when you have a broken bone, you go to the hospital and you get an X-ray, right? And then they can pinpoint exactly where that bone is broken, which will inform the doctor on where to fix the POP, right? Or if a surgery is needed. So the Amazon X-Ray is not so much different. It's a management service that helps you to analyze applications in AWS, right? So you kind of X-ray your applications, see where there are problems. So it's probably something that the developers will be using, right? So it helps them to understand how their applications and fundamental services are performing. It can help to identify performance issues and errors in that regard. So it does this by tracing incoming requests to your application and then using that data to make a point-by-point detailed service graph. So if there's a request to a service on a server, it's going to be tracing that request and seeing how it flows across the application, and then able to draw a detailed service graph and identify if there are issues or if everything went smoothly. So the service graph will show how your front-end services are handling data from the back-end services. And that can help you improve the performance of your application. So organizations will use X-Ray to analyze applications, identify bottlenecks, view performance analytics, and audit their data in a secure manner. And I'll show you what it looks like in this diagram here. So this is how the AWS X-Ray works really, right? So it's going to be tracing up requests that are coming into your application. So it's going to be collecting those traces, recording them, drawing that detailed service graph, right? And then analyzing issues if there are any, and then providing you with the results to show you where there are issues. Good too. Now let's talk about implementing a network audit strategy. Now, auditing is very important for all organizations because it helps you to meet compliance requirements, right? So if you're working in the financial sector, you want to have PCI DSS compliance requirements, and if you're working with a company that deals with customers in Europe, you want to comply with GDPR requirements. So you need an audit strategy to show that you are complying with these requirements, for example. So what exactly is a network audit? It's the process of gathering network data, analyzing it, and studying it with the purpose of assessing the network's overall health, right? So it helps organizations meet compliance requirements required for their IT infrastructure. So it's a systematic process that looks at your security, network security posture, looks at confidentiality, integrity, and availability of your systems, and gives you that an idea of the overall performance of your network. Now, how do you implement a network audit strategy in the cloud, in AWS in this instance? So to implement an audit strategy in AWS, these are some recommendations that can help you achieve this aim. So first of all, you need to define the scope of the audit and its intended goals, right? You need to keep it down because audits can be really large, right? You want to identify the services that need to be audited. For example, your firewall policies. It's important that you audit them, right? Your identity and access management policies is important that you audit them. Your security group policies, network access list policies, these are important policies that you want to audit from time to time just to make sure that you are in compliance. After identifying the network services that you want to audit, then you now define the tools and processes to be used in evaluating your network services. So are you going to be using CloudTrail as an audit tool here? Would that meet our requirement? Are we going to be using network scanners for audit trail? Are we going to be using AWS config, which shows us when configurations have been made or tampered with? Are we going to be using third-party software to carry out our network audit? That's some questions you have to ask yourself at this stage. Then we collect the network configuration data and that you want to audit and the accounts you want to audit. So this means firewall logs, firewall configurations, access list configurations, security group configurations, IAM policies configurations. You collect all this data and then you execute your audit plan using those tools that you've chosen to perform your audit, right? AWS has the AWS Audit Manager that you can use to audit your network, right? AWS Systems Manager is also useful in carrying out some audits. The AWS Config is also useful in auditing because it shows you who has made configuration changes to your network. So these are some inbuilt tools by AWS to help you implement your audit strategy. You could also use third-party tools, right? So you could use AlgoSec, which kinds of audits your firewalls and tells you when access policies have been changed and gives you timestamps and stuff like that. It's a third-party software that you can use to achieve this aim. And then finally, you want to review the results of your audits and then take actions on the results. So now let's talk about common network problems that you would come across in the cloud. right? Or in AWS. Misconfigurations. That's the very first one, right? And it's not so much that sometimes network admins don't know what to do, but it's just having that overall picture of the network and how these components are supposed to interconnect. So, for example, if you have a firewall in place, right, you're supposed to route all the traffic to the firewall, and then the firewall routes traffic to the internet gateway, right? So there could be a misconfiguration in place that allows an EC2 instance direct access to the internet gateway. So in that case, it bypasses the network firewall, right? So these are some common network problems that you find in the cloud. Misconfiguration is one of them. An EC2 instance can crash due to various reasons. One popular reason is installing untested patches on your EC2 instances, right? And this happens all the time. Microsoft will release a patch, and then 3 weeks down the line, they say, "Oh no, there's a problem." Uninstall that patch which was installed. So it could get problematic when you patch a system without testing it first. Of course, the CPU being maxed out can also cause a crash of the system. Another common network problem is when you don't have a route to a specific destination, right? So you have to always check your routing tables to see that your routing has been done correctly. Now, for VPN tunnels, what are some some common problems with VPN tunnels? A mismatch in maybe the encryption algorithm. So one side is using AES-256 and another side is using AES-128, or a mismatch between Diffie-Hellman groups or the hashing algorithm. These are some issues that can cause the IPsec tunnel to go down. And usually the IPsec, well, in some, I haven't seen it, but I assume that there's a provider somewhere that could upgrade their security device. So let's say you have a VPN with from AWS to a Cisco router or a Cisco firewall, and then they upgrade the firmware of the Cisco firewall, and then it no longer supports AES-256, right? So when that router comes up with the new firmware, the IPsec tunnel is going to go down because it's now going to default to another encryption standard. So these are some of the things. I've not seen it that often. I've seen a little variant of that in the sense that, so yeah, real life example. So when you build your VPN tunnels, right, you choose the subnets that you want to allow over the VPN tunnel, right? So if you have 10 subnets, for example, that you want to send over the VPN tunnel, you can create a supernet, right? Summarize it, right, and send it over the VPN tunnel. And then we try to build a VPN with another a partner, not with the cloud now, and it was working fine until we upgraded the firewall, right? I think it was a checkpoint firewall, and then the VPN tunnel went down. So after extended troubleshooting, we found that we had to specify those 10 subnets individually over the VPN tunnel for the connectivity to be restored. So you might run into some little problems like that where you have experienced people to help you solve the problems. Now, how about security problems? What are some common security problems you come across in AWS? Misconfiguration of your network access list. It's too restrictive, right? Same thing with the security groups. It's too restrictive, right? It could be it could be a software running on a server, right? That is identifying legitimate traffic as illegitimate and dropping that traffic, right? It could be incorrect identity and access management policies that has been configured in AWS. These are some common security problems that we'll find in the cloud. And then lastly, we want to talk about how we can eliminate risk and achieve efficiency in a cloud networking environment. So the first thing we have to understand is that all risks cannot be eliminated, right? But we can mitigate them. We can take steps to reduce the amount of risk that we have in our AWS cloud. So when it comes to risks, you could mitigate the risk, right? And like I said, you can't eliminate risk, all of risk. You can reduce risk and then accept the remaining risks, or what we call the residual risk. So you reduce your risks to an acceptable level, something that you can live with, and then work with that in your AWS cloud. So you would usually want to use a risk management plan to help you to reduce risks. And Mike mentioned some of that when he mentioned Pasta and Stride when he was talking about threat models. So you typically want to use a risk management plan or framework to help you manage your risk. Now, there are some technical controls that we can implement as networking professionals to help us manage risk in our infrastructure. One of that is encrypting your data. It's very key that to enforce confidentiality of your data, you encrypt it so that even if the data were compromised, the bad guy will have no use of it because he can't decrypt the data, right? You want to also use packet filtering, right? And this will be done at your firewall level. You want to filter the packets coming into your network and going out so that illegitimate traffic does not get in or go out, right? You could also employ a data loss prevention system just to protect what kind of information is taken out from your infrastructure. Use firewalls. Web application firewalls, they help to keep your web applications safe from web application attacks. And there are quite a lot of them. Cross-site scripting attacks, injection attacks, SQL injection attacks, buffer overflow attacks, and the likes, right? Having a web application firewall helps you to reduce the risk of being affected by these kind of attacks. You also want to use access control leaks and security groups as well. You want to do what we call segmentation of your VPC. Mike talked about a demilitarized zone earlier, a DMZ. So you want to compartmentalize your services so that if one compartment is breached, right, the bad guys cannot move from that compartment to another compartment. More like microservices, right? It's segmented so that it just reduces the blast radius. You can only affect this compartment that you've gained access to. So segmentation is very important. Then have a backup plan. You have to have a backup plan, right? You have to take backup of your network devices, of your firewalls, your EC2 instances, because one day things are going to get broken, and then you have to rely on your backups. It could be that you suffer a ransomware attack, and then the bad guy gets access to your EC2 instance and then encrypts all the data and says, pay me $1 million to give you the encryption key. You just call his bluff because you have a backup. Terminate that instance, delete it, spin up a new instance, and then load the backup there. And then, of course, find the hole which let the bad guy in and block it so that it doesn't encrypt your new EC2 instance. So have a backup plan. It's important for disaster recovery as well. Manage user access control, identity and access management. Who has access to your network? It could be a last form of defense, right? For your services. How about multi-factor authentication? It's important as well. Two-factor authentication. And when we're talking of multi-factor authentication, we're not talking of having a password and a PIN, right? These are two. We have different types of authentication. These are type 1 password, something you know, right? So you know your password and you know your PIN. Have a multi-factor authentication strategy that combines different authentication factors. So you want to combine a password and Google authentication app, right? Or Cisco Duo authentication app, right? So you have your phone. The bad guy doesn't have your phone. So when you enter your password, it sends a push to your phone. You click and accept the push and you get access to your network. So also you want to train your employees. Well, in my opinion, I think one of the easiest ways to gain access into a network is by social engineering. People always fall for it. I mean, I fell for it in my last job. My manager then, on a Saturday morning, sent a mail to all of us. And I was in the bathroom with my phone. And the mail came into my phone. And I couldn't really see the email header because that's something I look out for. Look at the email, and then you see whether there's a max email ID after the email, then you know this is scam. So I couldn't see it, and I clicked on it, and it told me, well, you have failed the test, right? I got a mouthful on the next Monday, but it can happen to anybody, right? So train your employees, employee awareness, security training, user education. It just helps to raise the level of the security awareness and helps you to manage the risk of having this infrastructure in AWS. So we can take some questions now, after which Mike, I believe, will talk about some hybrid cloud architectures.
Yes, absolutely. Hybrid cloud stuff, which I love. So let's bring in some questions. Who has questions for us? I'll read the question. Can we integrate VPC traffic mirroring with SNS notifications? Maybe the incident response team. So I'm not 100% sure I understand what the actual question is. Either of you, and it's hard in the YouTube chat box. I get it. Do either of you understand it?
So let me try here. So when you're talking of an incident response team, I would assume that it's a team that is monitoring a sort of SIEM solution, right? So that when there's an event, they can respond, right? You could send the logs from that EC2 instance to your central log location where the incident response team would have access to it. So yes, there'll be some correlation there, and then there'll be visibility into the logs now that I
understand the point, you could do that. And you'd also want to segment that because your incident response team probably has some lawyers that are attached to it. It has some PR people that are attached to it. It's got some senior executives that are going to be attached to it, and they probably don't need to know this. But the security admins that can fix this and the security engineers that would be part of your incident response team, that would be good, yeah.
Name not found. Why do we need to do all this monitoring and investigations on a mirror instance? Can all this work not be done on the source EC2 to save time? Well, I wouldn't want to be doing analysis on a production server, right? That is accepting traffic and responding to requests. I would like to offload that data to a separate instance and then do my analysis there. That's why I will do the traffic mirroring.
But it's more than that. If you try to do things on, you're really trying to find one way where you can look at the big picture. And by putting everything in one place and that one place can see everything, it's going to be able to make better correlations than if stuff's all over the place and you can't figure out how to access it. But it's really good thinking.
Sunday Okuns. Can we use a third-party application like Zscaler to block unauthorized IP? It's like asking, can we use a third-party application like a Cisco firewall to block unauthorized IPs? There's that possibility to use vendor devices from different vendors. It could be Zscaler, Palo Alto, Sophos, and the likes. As long as you have it in the... you could even spin up an EC2 instance and install the software there and use it to protect your network. Yeah, so you can. Shumak, if you automate the patching of EC2, are the instances when patching may block applications? Can you please throw more lights on data keys with encryption of data at rest? So this is a two-patch question, right? So if you automate the patching of EC2 instances, can it? Well, the first thing is that I would not automate patching of my production servers. When the patches come from Microsoft every second Tuesday of the week, right, of every month, I'm going to test it in my lab.
Yes.
I'm going to go to Microsoft's site to see if there are complaints about this particular patch. And then when it's certified that all is well and good, I can now push out the patches to my EC2 instances.
Yeah.
Can you please throw more lights on data keys with encryption of data at rest? I'm not sure I understand this question,
so
but
I think what he's talking about is the key management system and all the ways you can manage the keys. So it's a fairly big topic on key management and encryption at rest. But the good news is next month, i.e. June, we're going to do a full AWS Solutions Architect Bootcamp, and we're going to get involved in a lot of storage. And when we get involved in storage, that's really talking about encryption at rest. Having that key management system and the various storage things in the networking course isn't going to fit when we've got about 30 minutes to finish it. But I will definitely cover that at length, and we're going to be doing this course completely free, and it's going to be a pretty big solutions architect course, the one we ran before, plus a tremendous amount of new content and other things that'll be there as well. So we will cover that there. Is there an AI tool that can analyze all the logs and send alerts? There's been SIEM systems that have been doing this for a while, and they have been using AI for a while. Having said that, I can tell you many organizations that have high security environments have been taking these logs and streaming these logs with something like an Apache Kafka, creating an object storage type data lake, and then running machine learning algorithms and visualization tools to see what's been going on in their systems, so they could create their own things in addition to the commercial SIEM systems that are out there. Absolutely.
So Joseph is asking, when you create a backup of your instances or web application servers, do you create these backups in the same regions, or do you get charged by AWS for these backups? So the first thing that I want to do as a security professional is not to save my backups in the same production system, right? So if I'm running a multi-cloud system, I'll probably be saving my AWS backups in Azure or saving the backups on-prem, right? So that if there's a problem there, right? My backups are safe and secure, and I'm going to have more than one backups. Now the backups are going to be stored. If you decide to store your backup in AWS, you want to store it in another region, right? Uh, in another availability zone. You don't want to store it in the same place where the device is. It's like storing an encryption key on the server that you have encrypted data on. Once the bad guy gets into the server, he can just get the encryption key and and decrypt the data. So it's the same thing. Once your your infrastructure is compromised and the bad guy sees the folder called backup, he's so happy because he has got you by the jugular. So there are different type of backup strategies that you can implement, right?
And we'll briefly get into disaster recovery things soon, but think about it. If it really matters and you need some real critical backups, don't put it on the same cloud in case the cloud goes away.
Yeah. So Joseph is asking again, is the transit gateway created within a specific availability zone between various VPCs? And also, does the transit gateway act as a route reflector? I think Mo answered this the last time, that you can have more than one transit gateway in different regions and then you pair them, right? And then you can allow routing between different locations in the transit gateway. So I believe that answers the second part of the question. Does it act as a route reflector? I don't think routing is enabled by default, right? But you can go in there and allow.
Somebody has a loud motorcycle or car somewhere or something that needs a muffler.
But
the key when we're using Cloud Hub or Transit Gateway is that it functions like a route reflector, enabling, if we want to enable it for routing, multiple VPCs to be able to have a hub and spoke environment by allowing transitive routing, just like a BGP route reflector.
Shumuk is asking, is there anything like gateway logs? What application is gateway? Do you mean the transit gateway logs? Because I covered that earlier, that you can get login from your transit gateway.
You could be referring to routers, which are also called gateways, and routers generate logs. Not sure.
Yeah, is it fair to say that almost every resource, we can pretty much take logs from every resource and use it inside CloudWatch?
Yes, I mean, there's that capability.
Okay, well, we've got still an ambitious amount of content to go through in a short period of time. So we're going to get back to the content. If you just joined us, please note that we've got 2 full days or almost 2 full days worth of great labs for you to do. So please make sure you sign up for them. And they're free. So go sign up for them. They're in the description in the chat box. And so we know you're awake, alert, and oriented. Please give me a hashtag AWS Advanced Networking. And if you're enjoying the lessons, please give it a like, subscribe, hit the bell, those sort of things. So we're going to talk briefly about a hybrid cloud architecture, which is an incredible way to go. And a hybrid cloud architecture is quite simply having your data center and connecting it to the cloud. So that's it. And by leveraging it, you're eliminating single points of failure. You're typically saving money because cloud compute costs, when all is said and done, David Lithicum's numbers are 250% of data center costs. It's about what I've seen. So things that run 24 hours a day, 7 days a week are typically much cheaper in your data center. Things that run sporadically or need to scale typically need to run better in the cloud. So a hybrid cloud enables you to leave some of your things in your data center, some of your things in the cloud. Your high performance things that you need control over, you can run in your data center. the ultra high security things you can run in your data center under extreme security, and you can use the cloud for what the cloud is good at, which is scalability, near unlimited capacity, and simplicity, and capacity on demand. So that's your hybrid cloud architecture. And there's a couple ways to do hybrid cloud architecture, but one of them that we're really talking about is offload, hybrid cloud offload. So let's say we've got an organization and they've got their data center and they're running a private cloud on it, say OpenStack or Nutanix software, and they've got a private cloud. We can have it set up where those systems can run in that private cloud, and when they reach a certain capacity, add capacity in AWS, Azure, or Google when you need it. Pay for it when you need it, scale back when you don't need it. So that's what we're talking about data center offload. And basically speaking, we've got similar servers in our data center, virtual machines in the cloud, and we can scale out as we actually need. We can do it with web-based applications where we use Route 53 or DNS in an environment where we say 80% of the traffic in the data center, 20% of the cloud. We could set over a failover routing, run the data center completely, switch over to the cloud. So that's where we're really talking about it from a hybrid cloud, and where hybrid clouds really shine. So we're going to talk about leveraging the public cloud right now for disaster recovery. But here's the thing. Let's say we're in the AWS cloud and we want to do disaster recovery. We don't want to do disaster recovery in AWS. That's silly. That's like saying, hi, I've got a building and a business, and I'm going to back up all my stuff and I'm going to put it in my own business. No, that's silly. We put it somewhere else. Typically, our data goes far away. So if we're going to do really good disaster recovery, we can back up our data center in a cloud provider with great disaster recovery. And if we're on AWS, chances are we should, realistically speaking, put our disaster recovery on, say, Google or Azure, not just another region in AWS, because that's not real disaster recovery. Now, when we define a disaster recovery plan, here's what we need to think about. What is the business's maximum tolerable downtime? What is maximum tolerable downtime? The amount of downtime a business can have before their business has significant and permanent long-term losses. So we must know the maximum tolerable downtime. And that's an executive decision from that business. When we know the maximum tolerable downtime, we can come up with a recovery time objective, which is going to be less than the maximum allowable downtime, or the maximum tolerable downtime. And then we can also start looking at how quickly we need the data. At what point do we need to recover our data? Can we tolerate data that we lost for 5 minutes, for 5 days, for 5 weeks, or 5 months? And what's going to drive that is business needs. If we're dealing with a bank that processes 50 million trades an hour of stock, and we lose an hour's worth of trades, that's going to be serious. That bank cannot tolerate a recovery point of an hour. Maybe it can tolerate a minute. Maybe it can tolerate 10 seconds. Likewise, we've got another business that can tolerate a week's worth of downtime loss, and it's no big deal. So we have to think about that in the context of the business needs. So let's talk about our architectures for disaster recovery. And this gets a lot better with infrastructure as code, but the same principles apply. So the first disaster recovery architecture we're going to talk about is going to be the lowest cost. And basically, the situation is we have our systems in our data center, or we have our systems in a cloud. We back them up into another cloud. We back up in the forms of virtual machines, call them machine images, what have you. We have snapshots of our database, and again, an image of our database and stored database in another cloud. And if our data center goes down, we launch them on the cloud provider, or we launch them on another cloud. We launch all these virtual machines. It's going to take a little while to get all these virtual machines set up. It'll be a little quicker with infrastructure as code. It could take, a bit, a couple of hours to really get it up and running perfectly. And that's going to be our lowest cost disaster recovery. Copy our virtual machines someplace else, copy our data someplace else, and then poof, that's our lowest cost option for disaster recovery. What's our second lowest disaster recovery option that gives us a little better? Well, we take our data center, back it up into a cloud, we back up all those virtual machine images. Or we're in, say, AWS, and we back up all our virtual machines, and we keep a copy of all those virtual machines in Azure. Same thing. It really doesn't matter. And now we keep our databases synchronized. So if we've got a database, say, let's say an Oracle database in AWS, we synchronize that database in real time with the database in, say, Azure. So now, if we're using AWS and we're creating disaster recovery in Azure, we've got copies of every single virtual machine we have, and we've got a synchronized database. So now, if an outage occurs, we leverage an infrastructure as code script, we launch all our systems, and we've got fresh data from the database. So better than before, where we just backed it up and created backups of our data. Now we've got backup images, and a synchronized database. So it's going to come back faster with less data to be lost. Now, what we're going to get into next is where the cloud gets really beautiful for disaster recovery. Let's say all I have is a very simple 3-tier website in my data center. Or it could be the AWS cloud going to Azure. It doesn't matter. It's the same thing. But let's say I've got a very simple website. I've got 30 web servers, 30 app servers, and say 10 database servers by the time we're done with all our read replicas and everything else that we have. So 30 web servers in my data center. I now create an environment in AWS or any cloud I want. And instead of having 30 web servers up, I have 3 web servers up sitting behind a load balancer in an auto-scaling group. I have my app servers in here, but instead of having 30 of them, maybe I have 3 in an auto-scaling group. And I replicate my databases from my one data center or cloud to the other cloud provider. I create, say, a DNS policy for this architecture. Data center 1 fails, or cloud provider 1 fails, go over to cloud provider 2. And then what happens is all the traffic comes in to the second data center or the second cloud. The traffic will initially overwhelm all those servers because you only have 3 and you had 30 before. Auto scaling will occur. These servers will add capacity. And within 30 to 45 minutes, this system is up and it's running and it's functional. The data is carrying. This type of warm standby type environment is one of the benefits of cloud computing-based disaster recovery. Set up a very small environment, put everything in an auto-scaling environment, keep our data synchronized. One thing goes out, poof, within 30 to 45 minutes, you've got a completely up cloud and everything's up and running. So that's really where cloud scales, and that's going to work for really businesses that have, fairly significant needs, but they don't have to be up. And the last type of disaster recovery environment we're typically going to talk about is the hot environment. And here's what this means. If you've got a data center with 10,000 servers in it, you're going to have the cloud with the same 10,000 servers configured exactly the same way. And they both run up and up at all times. You're paying for twice the servers at all times. Should you have a problem in one data center, it will go down, traffic will shift directly to the other data center, and it's up and it's running and it is 100% capacity. So, cheapest option, backup of our information, backup of our virtual machines. Launch if there's a disaster. 2, backup of our information, backup of our virtual machines, synchronize our databases so it comes back quicker. Option 3, keep our systems in the data center and small versions of them on a cloud or backing up one cloud to another cloud, put them in auto scaling. Should anything happen in the primary cloud, everything will shift over to the backup disaster recovery cloud. Auto scaling will scale it out in 30 to 45 minutes and you're up and running. And the last option is identical copies. Same thing in one data center, same thing in the other data center, rapid come and rapid response time. So that's really what we're talking about. Now, at that point, you might wonder, why don't you just run 2 clouds full time and send your information to both clouds and not even need disaster recovery? But that's going to be a different high availability versus disaster recovery situation. So let's talk a little bit about storage gateways and what they are and why we use them in hybrid cloud architectures. All a storage gateway is it's going to be an appliance, basically a server, like a file server, that you stick in your data center. It's going to be a virtual machine, typically VMware. And what'll happen is you'll mount information on that server. If you pop it on the server, it'll copy it on the cloud. If you've got your information stored in the cloud, you'll be able to reach to that server and it's going to feel like, and that server will go reach out to the cloud to get to the data. So I'll give you some examples of what it's going to look like. Typically speaking, we have file gateways, we have volume gateways, and we have tape gateways. So realistically speaking, let's talk about a file gateway. All it really is, and let me show you this, because I think these are really cool topics, the way these gateways work. I think if I draw it out for you, it'll be pretty helpful. Bear with me. Okay, so here's your situation. You've got your data center, or you've got your campus. Let's call it a data center. You've got one server here called the storage gateway. It can be any of the types of the storage gateway. You've got your data in the AWS cloud. And let's say your data is sitting in S3, which is object storage. Object storage is not normal storage. You're not going to mount it with your servers as a general rule. So how do you get your information back into AWS? Well, realistically speaking, if you've got a network connection between AWS and your data center, and you've got a storage gateway here, your users will connect to this storage gateway, and it's going to look like a server. And it can either run NFS, if you're connecting to Unix systems. They typically can run iSCSI, or they can also run server message block if you're connecting to Windows systems. So you connect to the storage gateway, and if you store some information on the storage gateway, it's going to get pushed to the cloud. What if you want to access information from the storage gateway? That's okay too. Your users will connect to the storage gateway. The information will then be pulled from the cloud, sent to the storage gateway, and sent to the user. And one of the other cool things to think about these storage gateways are they actually cache information. They store that information so that the next time someone requests the same piece of information, if it's stored on a cache, it won't be necessary, where they won't have to reach across the wide area network to get it. So another graphical way you can actually look at these storage gateways here is you can connect to the cloud provider over these storage gateways and set it up where your information is put on S3. And you can even create a lifecycle policy where your information will be stored wherever it's going to be most cheap based upon your use case patterns and what you're actually doing. So, just a touch on storage gateways just to prepare you for this in case it's touched. So let's talk about our connectivity to the cloud. In a normal world, we either need a VPN or a direct connection. But what if you need real security, heavy-duty security on your direct connection? You can run IPsec over the direct connection. And by doing so, we've got a direct connection, which theoretically is private because of the 802.1q tags that we're using, and a layer 2 VLAN's a layer 2 VLAN. But this way, if somebody were to break into the AWS Direct Connect facilities and they stuck a protocol analyzer or a sniffer on a span port, they could see your traffic as encrypted garbage, so they wouldn't know what it is. So that's one of the reasons we like to encrypt information on the direct connection. Plus, the other component of encryption is that endpoint verification. If I'm connecting to Benedict, I want to know that Benedict is a Benedict and not someone pretending to be Benedict. So we can set up VPNs over our direct connections. So let's talk about the concept of a transit VPC very quickly. What if you wanted to take your data center and connect it to multiple VPCs that you own? So, you've got the option of VPC peering, right? For your VPCs, but your VPC peering is not transitive. So if you wanted to have an environment where you're going to connect from your data center to all your different VPCs, it's going to get relatively ugly. But you can actually create something called a transit VPC, and it's not that different than traditional networking. Here's what you do. You create a transit VPC, and you put a VPC that you connect to, and you then connect that VPC to other VPCs. And by doing so, you can use your transit VPC to connect your data center to your multiple VPCs. And in your transit VPC, you'll put a router, a virtual router, and you basically do it the same way we've done everything forever. There's a virtual router. We can set up BGP on it, and that's how we can use a transit VPC. So it's going to be a whole lot like this. We've got multiple VPCs. We create a transit VPC. These transit VPCs ultimately have a logical router on them or a virtual router on them. And in that particular environment, that transit VPC functions basically like any other networking router we've had for the last 30 years. And now, poof, we can use that transit VPC for networking. So let's talk a little bit about billing. So there's a lot of billing and expenses on the cloud. This is usually what typically shocks people. So normally speaking, when you build a network, you don't pay to use it. You pay for the hardware that you have, and then you pay for whatever your ongoing links are. But when you connect to AWS, there's going to be a lot more fees. So they typically deal, let's say, for your connections to the cloud. Instead of just with a normal wide area connection, I get a network connection between me and Chris, and I pay a monthly fee for the connection. Here, we're going to have to pay for the connection. We're going to have to pay an hourly port fee to have the port that actually exists. And then typically speaking, we're going to have to pay to send the data. Now, when we're dealing with systems on the cloud, we're going to pay data processing fees. So we're going to pay for the data that's going to go out our NAT gateways, for example, pay for the data that's using our load balancers. So understand that as we traverse the AWS network to go from point A to point B, they're also going to charge us for that too. So we're going to get billed for a lot of different things. Now, when you have a VPN, you're going to get billed for every hour that your VPN tunnels out, whether you use it or not. Same thing for your direct connect, you're going to be charged there. But depending upon the way your traffic actually runs will determine what you're going to pay. So kind of keep that in the back of your mind. If you are using AWS Private Link, you're going to be charged for every hour that you've got a VPC interface endpoint. And you're also going to be charged for every piece of data that traverses that VPC endpoint. Same thing for the NAT gateway. You're going to be charged as long as you have the gateway. Then you're going to be charged for the traffic that's processed by your gateway. And then you're going to be charged for the traffic that's sent by the gateway. So process, sent, and you're going to be charged for the NAT gateway. Now, there's also other service and port hour fees. There's going to be load balancer fees. You'll be charged for the number of hours the load balancer is in operation. You'll be charged for the load balancer capacity units, which are going to be a combination of traffic flows, bandwidth uses, and the number of rules on the load balancer. So the smarter you configure these load balancers, the more you're going to need to pay. Typically speaking, outbound traffic was always billed to the internet. There were some changes very recently, started with Google that's not charging, and I believe AWS just caught up. And you will also be you will pay for region to region transfer. So if you've got something set up in the US and now you're dealing with a region in Europe, you'll be charged for those transfers. So sometimes if you had object storage in an object storage based website in the US and you had a lot of users in the UK, it may make sense to replicate that object storage to both sides of the pond in the UK and the US and have the UK people and European people served locally as opposed to being served from the US. And of course, there's also going to be a charge for any type of data in and out of the CloudFront content delivery network at the edge locations. Now, if you're using public IP addresses in the same region, there's going to be a data transfer charge. So try to use private IP addresses when you can instead of public IP addresses, because that way there'll be less communication charges going back and forth. And of course, if you're going to put your data in 2 different availability zones and your systems between 2 different availability zones for high availability, there's going to be additional fees and charges for that. And of course, any data you go from VPC to VPC will also be charged. So if you want to use micro segmentation of your network, for better security, please understand that's something that you're going to have to contend with. So we'll briefly mention the concept budget just in case it pops up. Budgets are a way for an organization to help monitor their budgetary requirements, meaning set up a budget to be alerted when you're spending a certain amount of money. If you're doing a lab, you might set a budget for $50. Why? Because $50 will get you a whole lot of labs for a non-production environment. But you can set up a budget that goes off at 50%. So if for some reason today you're at $1 and all of a sudden you get an alert, you're at $25. What did you do? What got left on? So you can fix it fairly quickly so you don't have a big expense before you get it. Basically, you'll set a budget, the budget you create in the management console or the billing console. And when you get to a percentage of exceeding that budget, you will be notified of it. And then briefly, we'll go into AWS Trusted Advisor. Now, in reality, a trusted advisor is a human person that's got areas of expertise. They have absolutely no bias in them. And you go to them for expert. Like if you go to your physician, they're typically a trusted advisor. Hopefully, they're not bought off by the drug company to go prescribe something for you. They shouldn't be. And you're going to go there and they're going to look at you and they're not going to say, I have a preference for this company's medications. They're going to be trusted. And AWS has a service, an online tool to kind of help organizations control their spending. And basically how it works is Trusted Advisor will scan your infrastructure. It will compare your infrastructure to AWS best practices and it'll make recommendations. But remember, it's an automated tool. You may get some wacky recommendations. But when the recommendations are good, it can improve your performance, your security, your availability, and potentially even your costs. And there's going to be 2 versions of Trusted Advisor. For organizations that are on basic and developer support plans, they'll get 6 security checks and 50 service limits checks as part of their Trusted Advisor. And for organizations that have business or enterprise support, they'll receive 115 Trusted Advisor checks, of which 14 will be cost optimization, 17 will be security, 24 will be fault tolerance, 10 will be performance, and 50 will be service limits. Well, it's going to go back to Benedict to talk about AWS networking limits and quotas. And we are running a few minutes behind, but not too many. I tried to go through some of those more easy materials fairly quickly there. So we'll come back. Benedict, for time purposes, why don't you go straight into networking limits and quotas? But you're muted, Benedict.
Thanks, Mike. All right, so is the cloud infinite? No. There are limitations to cloud, right? So AWS has networking limits and quotas that can affect usage and performance. So you have to be aware of this, right? It's important to be aware of these limits so that you can plan your network resources accordingly and you don't exceed these limits and quotas. Although if you hit the limit, you could contact AWS support team and ask for a service increase. So they have a dashboard where you can go and track and manage the quotas for each of these services. So AWS places limits on the number of VPCs, subnets, security groups, direct connections, and virtual interfaces that you can create per region, right? So there are also limits on the number of NAT gateways and elastic IPs per subnet that can be allocated per VPC. So what does this look like really? I'm going to take you to the dashboard of the limits and quotas page on AWS. And share my screen now. Thank you. So this is what the dashboard looks like, right? The quotas and service quotas dashboard, right? So you have a dashboard and it shows you the different services. So I'm in the current region here and tells me that I have I can create 155 EC2 instances in this region. 24 CloudFormation instances in this region, and stuff like that. So what if I hit the limit and I want to go beyond that? I want to create more instances. What I would need to do is to search for that application or that AWS service that I want to increase the quota, right? So I'll click here on the left on AWS services. Then here I'll just type the name of the service that I want to request an increase for. So for example, here it's Amazon CloudWatch, right? And then it takes me to the service page. I'll select the quota name that I wish to apply for a quota, right? And then takes me to the next box and asks me how many instances do I want to increase it by. So if I need an extra 100 instances of the CloudWatch service, I'll just type in 100 and then click on request, right? So this request will go to the AWS support team backend, and they'll review the request and grants my request if they are able to. So just keep that at the back of your mind that there are networking limits and quotas when we are dealing with AWS services. So that's all from me, Mike.
Okay, thank you so much for that, Benedict. I am going to go briefly into high availability network design, or at least the things you can think about for the exam. I'll then talk a little bit about things you can do to pass the exam, and we'll finalize with questions. So let me know you're awake by typing a hashtag AWS Advanced Networking into the chat box. If you're having a good time, you're learning something, please give this video a like, and please subscribe to the channel and tell others about this video and our channel in general. So let's talk about high availability system design. And we have to define, what does that mean? And what is availability? Availability is your systems being there for you to use when you need it. So if I want to turn on my electric and I try to turn on a light switch in my house and I can't do it, the electric is not available. I'll put on some candles, I'll hang out with my cat, maybe drink a glass of wine. I might think it's fun. Somebody else might not be so happy about it, but availability is not. So when we talk about availability, we'll typically talk about three levels. We'll talk about it in number of nines. 99% versus 99.9% available versus 99.99% available versus 99.999%. Now, I'm going to tell you right now that I have designed many 5 nines available systems, but 5 nines available systems, meaning 99.999% of the time, is realistically speaking 5 minutes and 25 seconds of unplanned downtime per year. So it's really nothing. Most organizations would consider 99.99% high availability, most organizations. And what determines the amount of availability needed? The organization's business needs. What is the cost of downtime from a quantitative and a qualitative perspective? And you have to calculate that with that organization's executives. It's something we teach our cloud architect students because it's very vital. Because if you don't know the business and you don't know what you're designing for, you can't plan those. So, wrong button. So let's talk about where you would need these. So most businesses, 99.99% available, gives them about 52 minutes of downtime. It's fine. But what if you're a bank and a minute of downtime could be millions of dollars? What if you're a hospital and when your systems go down, somebody dies? Or an emergency services system where you go to call 911 in the US or 999 in an emergency and it isn't there. That's where you need ultra high availability systems. So let's talk about principles for system design. No single points of failure. So realistically speaking, if you have a mission critical system, like an emergency call system, or an entire government's military, or a bank, you probably should not put it all in a single cloud, because no matter how many availability zones and regions you use, that cloud provider becomes a single point of failure. So you should spread that load. For more moderate availability systems, we're dealing with something else. So let's talk about things that you need to think about in high availability. I'll first start with the tech pieces. Redundant power. If you've got a router connecting to the cloud provider and that router dies because the power goes down, you got a problem. So you should probably be dealing with high availability routers which have multiple power supplies. Lose a power supply, you're fine. And each power supply should be put on a different power distribution unit on a different circuit breaker. Blow a circuit breaker, system goes down. Cooling. You know, in your data center, if it's a private cloud, you better have redundant cooling systems, because if the air conditioners go down, your data center stops. The cloud provider should hopefully have redundant cooling. Redundant network connections. If you're going to connect to the cloud, you need more than one provider. It could be a private line or a direct connection and a VPN. It could be two private lines, but on different service providers, not on the same one. Because you've got two lines on AT&T has an outage. It doesn't matter how many lines you have, you're down, you are done, and that's no good. So let's talk about routers. Our routers may need to be high availability routers. That means, you know, a router has a brain or a control module. If it really matters, we're going to need multiple control modules. On the links between our routers, maybe they're on different line cards, because the routers have cards, and if a card fails, your system goes down. It means we need servers, more than one. We need switches, more than one. We need load balancers to eliminate single points of failure. We can leverage DNS to route between different websites or different clouds. Our storage, we need to have redundancy, so that if one storage system goes down, then another thing. And potentially RAID. We might have two different storages where we're running active, and if one of the storage arrays goes bad, we can pick up the second one immediately with no loss of data. So our applications need to redundant. Our databases need to redundant. I hope you're getting the point. So think about this. And, you know, for example, let's say I wanted to get a link aggregation group to the routers that's going to connect to the cloud. If all my links in the link aggregation group are on AT&T, I got a problem. So what if I need 40 gigs of throughput at all times? I might need 4 10-gig connections to AT&T to AWS, and maybe 4 10-gig connections off of Verizon. So let's think about that. Now, firmware-wise, don't experiment when you're dealing with high availability systems. You know, this message I got over here, I thought was hilarious. It actually showed up on my firewall. And when I looked at this, I actually laughed. Could you imagine a high availability system telling you this? Your security appliance is running stable firmware to try some of our new features we've been developing. You know, click here for beta. Don't use beta software in a high availability environment. I mean, seriously, you would think it's a joke, but no, the firewall I have in my house, which is made by a major networking company and security company, actually says that when you log into it. It's ridiculous. So your systems need to be checked, etc. Now, when it comes down to it, you can do every piece of technology right, everything. And then you can have Sally, the computer tech, or Billy, the computer tech, that goes in at 2 o'clock in the morning and creates one access list on the network and breaks everything. So you're going to have a very good change management process in place, which means anytime a change is desired, you're going to have to present the change to an architectural review board. That architectural review board is going to have managers, stakeholders, department heads, and they can all evaluate your change request and determine if your change will have any impact on the global system. And if it does, but it's still needed, find a time where you can do it where it's least impactful for the business, or don't make that change if it's not the right change for the organization. Now, it's a little easier with the cloud provider to get high availability, because for the most part, they're pretty good at what they do. They have redundant power, they have redundant cooling, they've got redundant connections to the internet, their switches and routers are redundant, so it's there. But there's also much more that can go wrong on the cloud provider, because they can't run QoS the way we can. They can't run as invasive of security measures as we can on our own systems, because they have to allow for everyone's traffic. So what I'm going to give you now is best practices according to the cloud providers for your exam. But what I tried to tell you before is exactly how you would do it in the real world. But it's a certification, not the real world. So if 99.9% is, so each availability zone in AWS is considered 99.9% available. which means if you need 99.99% available, you need to use 2 availability zones. So typically speaking, in a theoretically perfect world, 2 availability zones in a cloud provider, and you have 99.99% availability. Believe me, there's a lot more that goes into change management security, but for right now, for your exam, just understand that. Now, according to the cloud providers, if you went higher than that, instead of you put 2 availability zones in 2 regions, and then you've got 4 total availability zones, and that should give you 5 nines availability. That's great until the cloud provider has a security event, a network event, or has a problem with their control plane, and the entire cloud goes down. And we've seen that too. So I wouldn't put all my eggs in that one basket. But anything that needs high availability should be in multiple availability zones at minimum. That means important virtual machines, important databases, load balancers, DNS, everything. So connections to the cloud. For most people and most organizations, it's going to be a direct connection and a VPN backup. But if we need link aggregation groups for bandwidth, we might need a redundant link aggregation group. So just think about that. And ideally, if you're going to connect to 2 different links, they probably should be on different routers at your data center, because if that router, your data center, has all your links to AWS and that router dies, you lost the whole cloud. Now, when we're dealing with high availability, security has a major impact here. So when it comes to security, leverage security properly. That means leveraging the least principle of least privilege with regards to our identity and active management systems. It means disabling unnecessary services that we don't need to run on our systems, because each service that we run is a new attack vector. It means making sure that patches are tested and that systems are patched on a regular basis. It means limiting the blast radius of problems, either by segmenting your system into multiple VPCs or using AWS organizations, or a combination of both. It means keeping unwanted traffic out of your subnets with access control lists. It means protecting your hosts and your services with security groups. It means leveraging firewalls and next generation firewalls and DDoS protection and IDS, IPS systems. It also takes physical security, because if anybody can just walk in and plug into your systems, now they can access your system. So think about that. It requires strong passwords when strong passwords are needed. It requires using tokens and other things when it's at all possible. It involves templating good system configurations and making sure your people can't deploy the wrong things and break the system. It means high availability means good backup strategies to protect against lost data that are based upon the business needs. And how much tolerable downtime can they lose, for example? And how much data can they lose? It means storing your backups in an alternative location. When I was a kid, I backed up my papers that I wrote on a floppy disk. And then, but it was like, what happened if my house caught fire? So what I used to do is then email anything that was important to everybody that I knew. The point is, I got it off of my house and out of my location. And it's the same thing with data. Send your backups somewhere that you own or somewhere that's secure, but away from you. Take images of all your servers so you can come up with, and should anything happen, you can relaunch those servers immediately. Your routers and firewalls are typically going to have a text-based configuration. Copy those configurations somewhere so you could launch them quickly and easily if you needed. Now let's think about it. If we can decouple our architecture components, we can also tend to increase scalability. So if we have messages that are going into a database, but the database is down, but there's a queue before the database, we can store those messages in the queue. We should, part of high availability is making sure the systems can scale with demand. Cloud's great here with regards to auto scaling, and we can leverage that. We can leverage caching, because I talked about earlier how, for example, if your web server was down temporarily, but the information was cached, your users could potentially still get access to the information. And we talked a lot about DNS and how we could use DNS to route in between environments for high availability. And we talked a lot about leveraging load balancers to improve performance and mitigating single points of failure. Part of being able to keep your systems highly available is to know what's going on. So Make sure there's a good logging and auditing function. In today's world, there should be some security event monitoring systems to correlate things that are going on. We want to be moderating for systems alerts. We want to be moderating for security breaches. We want to be moderating for usage, and we want to be monitoring for performance. And again, change management is going to be so critical that we need to be, before any changes, key stakeholders need to evaluate those changes, the impact of those changes, and agree on a time to make those changes, and agree on a testing system after those changes. It's about as much high availability as we could do here. In our main architect training programs, we get very heavy into high availability system training. But let's talk about passing the exam. Here's the thing. All AWS exams are challenging. It doesn't matter what they are, they can make something challenging. And the reason is the way AWS questions, they can pick little minutia from any parts on the curriculum. But what really makes this exam hard is not the content on the exam. That's not that complicated. But the way AWS asks the questions, they are very wordy. Something you could ask in, 10 words might be asked in 80 words. And there's going to be a lot of jargon and acronyms, and it's going to make it feel like you're doing it and reading something in another language. And then you're going to have to translate that into what it actually is. That's the biggest challenge of the exam. Plus, there may not be a clear winning answer. So I want you to think about this, because here's where people go wrong on these certification exams, if they know a lot. These certification exams are based upon the entry-level person that just took a certification course and passed. So if you're a network architect with 20 years experience, you probably know too much. So if that's the case, you're going to struggle when you take this exam. So if you've got a lot of networking background, I want you to think just like the training material and the way it's presented, because we presented it at more of an intro level, and you will be fine, because that's the thinking they need you to have when you take the test. Kind of like when someone graduates and they take their medical boards out of school, they know exactly the school answers, but 20 years later, they know exactly how to do it in real world. Same thing here. Consider yourselves fresh out of school. Look at the AWS curriculum and then master it exactly the way they want to hear it. And then in your real world, do it exactly the way it needs to be done. So you're going to look for the best answer for the bunch. So I've got some recommendations. Go through this program a second time. Personally, I actually like to read the Cybex books. And the reason I like to read the Cybex books is they are typically authorized by the providers themselves to create official curriculums. So I typically recommend the Cybex books. I typically also recommend reading the AWS white papers, because they'll pull a lot of exam questions from your white papers. And for me, I recommend getting a practice test. Why? Well, the point of the way Amazon asks questions can be very tricky with their wordiness. And if you get used to the way people ask questions, then it becomes normal for you. And by getting a practice test and taking the practice test, you'll be in a position to understand the way they ask questions. And truth be told, the practice test can identify gaps that you don't know, and then go research anything you don't know and research it well. If you got a question wrong in the practice test, research what was right, why you got it wrong, and the thing that you thought that was right, why it wasn't right. Make sure you learn that. And I generally recommend keep working on any practice test until you can score a 95 on every attempt, and then you'll pass every exam for the most part you've ever done. So there's that. Now, I want to mention this. The hardest part of the AWS exam is the wordiness. These things are written so hard to read, so that's the hardest part. So the night before the exam, don't stay up till 3 o'clock in the morning and drink 10 martinis because you thought it would be fun. Go to bed early, eat a healthy meal, get a good night's sleep, arrive to the exam early. If you're going to a physical center, get there 30 minutes early. If you're taking it virtually, arrive 20 minutes early so when you log in and they're not there and your system freezes, you're going to be okay. Make sure you bring photo ID with you. You'd hate to study, prepare everything, and not have your photo ID with you. And if you're going to drive there, please give yourself time to park and give yourself time not to be stuck in traffic jams. So That's my guidance on passing the exam. Chris, bring us back on screen. And we will be back to finalize anything. We can probably take questions, but we have to finish at 6:30, which is about 30 minutes late, because I promised somebody that I would make sure that I was available to them then. Is disaster recovery done at the data center level or per application level based upon criticality? It's based upon the business needs. We have to understand the business needs to determine what we need to put in disaster recovery. Great question. So is it correct to say backup pilot light to another cloud provider while warm and active in another region due to cost? So I'm going to try and get rid of any jargon whatsoever, because everybody has their different jargon. You've got the following options. You've got backup, which is basically you back up your data and you back up your virtual machines to another cloud. You have what I like to call backup plus, which is you back up your data, you back up your virtual machines, and you synchronize your data. You can have what I like to call active semi-active, or warm standby, which is basically you have your primary environment and you have it replicated. And it can be replicated to another cloud. It can be replicated to another region. Now, I wouldn't replicate it to another region, because if the cloud goes down and you replicate it to another region, you're kind of out of luck. So that doesn't seem like the good disaster recovery for me. So warm standby, I'd replicate it somewhere else. But it would be the same if you're in the same cloud or a different cloud. The only difference is your IP connectivity. And then active is hot, full things running in one versus the other. And by doing so, you get the best performance. Do you need a router on AWS? Anytime you're going to route, you need a router. So in a transit VPC, you're basically using a software-based router, right, Benedict and Mo?
Yes.
Yeah, it's a virtual router.
So is transit VPC regional or global? Technically, it's regional because it's an architectural pattern, right? You're creating a transit VPC, you're setting up your VPN tunnels, and then you're using transit virtual routers, right? And then you're running traffic through those routers. So it's regional. I can answer.
So it says, can you expand on what a transit VPC logical router is? Is it an EC2 instance with router software installed, or is it an AWS resource? So it's an AWS service, right? But what is happening in the background is that there's a virtual router that is doing this routing between all your VPCs. So technically, yeah, it's just that it happens behind the scenes and they present that service to you. So Manish, I tried to put in this the response to this. The screenshot I showed was actually CloudWatch and not CloudFormation. So the quota was on CloudWatch.
Samsung, honestly, I came with low expectations, not knowing how you run it, but you guys did an amazing job. Thank you. Superb bootcamp. You all earned trust big time. Thank you so much. It's really essential for us at Go Cloud Careers. We really want to go out there and help people. And whether it's our paid career programs where we're working on every aspect of someone's career, or our free tech training, it matters to us. We want to really help those that are out there. We all come from a world where, we had to work ourselves to get anything, and we want to share as much expertise as we can. So thank you so much, Samsung, and thank you for coming. So much learning on this bootcamp, Cantor. This is great. Thank you. A million thanks to Mike and team. Yes, please thank the team as well. I got to say, Mo and Benedict are rock stars. let alone the team behind the scenes that made this possible, like Chris and Tyrone. I mean, there are people all over the world. Tyrone's in there at South Africa. It's like 11 o'clock at night, and he's still been around helping Chris, and Alonzo's helping, and there's a lot of people behind this. So thank you so much.
Can we minimize maybe cost per client VPN endpoint? So are you asking how to minimize the cost for client VPN?
Don't use it. They charge you for everything.
So, Joseph, when replicating between two different public cloud providers, how do those services understand one another in order to synchronize?
Okay, what a great question, Joseph. So we do this the same way we've dealt with things for the last 30 years. So I'm not going to have Amazon DynamoDB and Google Cloud Bigtable and try to synchronize these things. That would be like me trying to synchronize Greek with Mo's Arabic all at the same time. That's going to get ugly really fast. I translate every day of my life, but it gets ugly really fast because some things don't translate. But if I use Apache Cassandra in both clouds, it's nothing to get them synchronized. If I use the Palo Alto firewall systems in both clouds, I can push similar policies. So what I'm going to do is not use the cloud provider's proprietary services. I'm going to use more standard services that work in all clouds. And here's the reality. You're going to get a better firewall from people like Palo Alto that basically 90% of their business is firewalls than from AWS, who is a great company, but they make hundreds of different things, let alone being a retailer. So, it's not like, they can have the focus on a firewall the way a Palo Alto could. No, we don't provide any kind of practice exams. I wish we did. We work really hard to not try and charge for certification materials, but there are some good ones that are out there. T-Town Scott, really appreciate it. We're thrilled you're here. Martin, great boot camp above and beyond, and thanks so much. Thank you, Martin. And Valerie, thank you so much. I was thrilled that you're here. I look forward to seeing you soon, Valerie. Richard, always good to see you. Wonderful to see you. It's been an honor to work with you. Mo and Benedict, thanks so much. And Adrian, always good to see you as well.
Thank you.
Okay, so everyone, it's been wonderful. My team, if you haven't gotten a copy of the labs, will pop in some lab opportunities for you. I will pop in one day this week, possibly even tomorrow, to answer any tech career questions on our YouTube channel. So if you're not a subscriber, please subscribe and hit the bell. You'll be notified of it. On Thursday this week, we're going to run a How to Get Your First Cloud Architect Job webinar. And I may have a special guest who's been an architect with me for a couple decades as well, if it works out time-wise. So please join us. You can ask me or any of our architects any questions. And thank you for being here. And thank you for being here from all over the world. I know where some of you are coming from. I've seen your names. And I'm so flattered and honored that you joined us from everywhere. I can say everywhere from Egyptian, and I think I saw in Eritrea as well. So, we're there. I saw people in Asia. I saw people in India. I saw people all over Europe, the Middle East, and South America. So thank you so much. Have a good night, everybody. Make sure to sign up for the free things we have for you. Take care.
All right.